Okay, test. That should be live. That looks fine. Hello, everyone. Welcome to one more stream of the compiler project. Today, what's new today? Today, I want to continue working on the parser and the AST because we left things kind of in between at the end of last stream. And I'd like also to start by going back to the Lexa because I found some mistakes and some things we have missed, or some things that are incomplete at the very least. So, yeah, that's about it. No new update otherwise. And yeah, let's get started. So, the things I wanted to go back to first in the past in the Lexa, there's a comment I put last time which actually is wrong, and I'd like to fix. Here last time I said to do only increment position if byte is empty, and that comment is wrong. So we're gonna have to talk about Unicode, and there are things about Unicode I'm not super familiar with, but we're still gonna have to cover some basics. Alex works byte per byte. It is a thing that has been a problem for us in the past. Every time the parser calls the Lexa, it calls get byte and expects one byte, a word 8, at outside as the next thing to process. The problem is, it's for a while now, characters have not just been bytes. In some char sets like ASCII or other variations, yeah, sure, every character is a byte, but in Unicode, UTF-8 and others, no, a character can be more than one byte. And actually, in Haskell, the character type, is a Unicode code point, which I think is up to 4 bytes. So that's the reason why we do this decomposition into bytes. We encounter a Haskell character, which is a Unicode code point, and since Alex wants bytes, we have to decompose it into a series of bytes. And what I was afraid of is if we increase the location on every byte we encounter, we're going to say, oh, we're currently on column 6, but that's not necessarily true. That would be the 6th byte of the line. Thankfully, this comment is wrong because we test at the beginning of the function if there are bytes from the previous character that we haven't returned yet, and we return them. Otherwise, we pop the next character from the input stream, and we increase the location. Therefore, we are only increasing the location for each code point we encounter, which means we don't have the problem of increasing it once per byte. So that's fine, right? Except, well, no. Because the assumption here is that every code point in the input text is one character. And that's not true either necessarily, because, well, the word character is extremely overloaded, so it's going to be hard to like pinpoint one meaning. But when you see one character in your IDE, one thing like in a monospace font that takes one space, it might not be one Unicode code point. For two reasons. The first being some code points are actually modifiers that will alter the previous code point. Meaning, for instance, if you encounter a with an accent, it could either be the Unicode code point A with an accent, or it could be the Unicode code point A followed by the Unicode code point modifier. The previous one has an accent, which means one character in your IDE would be 2 code points as far as the Unicode representation is concerned. So that means that the code that we use at the moment that increases the column count by 1 per Unicode code point we encounter is wrong. The problem is it's gonna be very hard to fix. I could try to test whether the code point I'm encountering is a modifier for the previous code point, and in that case, not increase the column count. However, there are cases where some code points are merged and not all of the code points in it are like modifiers for the previous one. For instance, emoji. Emoji is usually a combination of several emojis that are fused into one. For instance, the trans sprite flag is the rainbow flag with a trans symbol. And if those two emojis are together, that makes one emoji, which is the trans sprite flag. Which means there's no good universal rule for like how do I determine the number of graphemes from the number of code points. And I could try using a library for that, but I end up having to know the local in which the ID in which the code was typed is set. That's a nightmare. I looked at what some programming languages do, and they just don't care about the column count. What Haskell does is exactly what we do: increase the line count on every new line, increase the character by one on every code point. They also do a thing with tab that we don't do, but otherwise we do the same thing as Haskell. So interesting tidbit. Unicode is a mess. We're not gonna try to handle column count properly. Another thing we missed in Alexa last time, and if I go back here, we forgot to handle comments. So at the moment, if there's a comment in the code, it's just gonna be passed either as an operator, like it's just not gonna work. And there's another thing we forgot last time, and I'm gonna mention afterwards. So first, let's take care of comments. There's going to be a lot of things we have to do for this, because we're going to have to be able to say, at the moment, the type of the Haskell expressions in this is this Alex action, which always returns a parser of a location and token. We are going to need to be able to tell it, actually skip that. This action like does not return a token there, or at least, or have a way of saying, actually, this action calls another action to get the next token, because when we encounter a comment, we just skip it. I've been thinking also, we might be tempted to try to preserve comments, either by having a token that is a comment, or by bundling any comment as a previous, like in the previous token. The only upside of this would be we might be able then from the AST to regenerate the exact source file, because we would know exactly what comment was in the source. So if we wanted to use our AST for source transformation things, having each token remember the spacing and the comments that we're after would probably be a good idea. In this case, I think we don't really care. So let's get started. So first, I'm going to change a thing here. I'm going to change this to actually be this. It's going to work the same, but it's going to make the syntax highlighting a tiny bit better. We're going to want to handle. So first, when we encounter // which is the line comment, I think it's just going to be // followed by anything that is not \n. Yeah, I think that's correct, because it's try to match the longest possible thing. So it's gonna match anything up to the end of the line. And we are gonna say that this is just a skip. We don't have to process this. What's gonna be a bit more complicated, however, is handling comments, like long comments. And in this case, I am going to do it manually, I think. I don't think I want to do nesting. I don't think I want to allow a given number of opening comments have to be matched by the same number of closing comments. I don't think I want to do that. That's I think too much work. So let's just say make comment. And that's gonna be a function here. But there's one more thing I'm gonna do before I actually do that, which is here in parser, I have this Lexa function, which is how does the parser call the Lexa? And the structure of it is basically always the same. It is get the next token. And we have, at the moment, two variations of exactly this function. And having access to it, just like give me the next token, would allow me to implement a skip, kinda. So what I'm going to do is I'm going to move this function in here, which is not exactly a parser. So it's not going to be exactly an Alex action. So I'm going to put it elsewhere. I'm going to put it here at the end. This is Alex get next token. And it just returns a parser for a location token. And what we do with it is we keep the same thing that we have before. We don't have the callback anymore, but that's fine. We get the current state. We call the Alex scan, which is what it needs to be in this file. We need to have access to the Alex scan function. And in the case of the end of file, we just return the tuple, parser location, end of file token. We do everything the same here. In the case of a skip, we just get next token recursively. And here, when we call the action, we will get a parser location token, which is what we want. And there is no callback. Okay. The upside of this is now this function, this entire function, is... Oops. Parser? Oh, why it changed on disk? Interesting. This function now is just we call Alex get next token, and we bind the result into the f callback, which means we can rewrite this as just this. And that means also we can rewrite this one. The go here, I think, is just... Yeah, I think this is going to be somewhat similar. We're going to be able to call, this is Alex get next token. And we are just going to transform the token we get. When we get some... When we get something that doesn't matter and the end of file token, we return nothing. Otherwise, we get a pair of token and location, which we're gonna call token info, and we return just the token info. I think that should work. So basically filtering the end of file token, which is gonna be a tiny bit, that is a tiny bit simpler. And at this point, I could probably... This is run parser of unfold m of a function, which happens to be this. I don't think I need the where anymore, since I'm not gonna call it recursively. Okay. I guess to make this a tiny bit more... Nah, I think that's fine. Unless there's gonna be some priority issues between the fmap here and this call here. So maybe fmap filter out end of file. And that way, this is a bit more clear. And filter out end of file is this. Okay. Now that means I can go back to the Lexer. I wonder if it's because I reverted some changes I didn't commit, that I had the file change on disk, probably. If we go back here, we can... Yes, we were doing the comments. So handling a comment, that's going to be an Alex action. So it takes the previous state, the location, the text that we matched, and returns the parser. So we don't need the previous state, that's fine. The location that we got, I don't care about the text because it's just the opening comment, so /star. That's fine, I don't need that. What I just need to do now is skip basically the next command. So let's get the current state. I want the previous state. I want the current state. Do I have a function? There we go. I'm gonna copy this. Now, let me quickly look at text. Is there a split or something? Function split on. There we go. Split on. String to split on. If the string is empty, okay. Yeah, that's perfect. So what we want to do, but it's gonna split on the very first. That's not what we want. It's gonna split on all of them. That's not what we want. We want to find the first. Is there like a take while or something? There is a take while. We could do that. Or I could do a split at, which requires knowing the index, but then I can do a find, I guess. I'd prefer to do something that doesn't. The problem with the split at and the find is that we're doing two traversals of the input string, which is a bit ugly. I would probably rather. It might be easier to just manually. It might be easier to just manually traverse the string, basically, rather than trying to rely on one of those. Let's do that then. We are gonna go. This is gonna be the same thing as we do for strings, basically. It's gonna be while we are not on the end, while we did not consume the end of string, then we can. I have this Alex try here. Do I have anything that is a bit more? Yeah, it's gonna be that. So basically, while not end of comment or something, discard current character. End of comment is going to be. So Alex try, that function I did last time. Let's go back to it. I think it only takes one character, right? Okay, so it only consumes it. That's annoying. I can't use it. So it consumes the character if only if the first one matches. So I can't do a thing where I try two characters in a row. That doesn't work. I was thinking I could do a two Alex tries and I return true if both of them have returned true, but if only the first one matches but not the second one, will have popped the character. Is that a problem actually? Actually, it's not. Because if we encounter a star but the next character is not a slash, that's fine. But I would need to know. I would need to know how many of them I have popped because otherwise. Okay, let's not try to do something too complicated with the existing functions. Let's just make a new function that does what we want. So this tests one character. This one is going to test several. And now instead of doing this, of doing the Alex get byte, what I'm going to do is I'm going to have to redo a few things from scratch. That's annoying. That is annoying, but that's doable. So this is basically similar to what I'm doing here. I'm doing a get matching car. Or I could do a thing where I always restore the previous state in case it failed. That way, if we only consume the two characters, if we match the end of the comment, otherwise we just always pop back the first one we matched. That might be easier, rather than trying to do a bunch of additional string manipulation functions. Let's do that. So I get back to this. So end of comment will be we get I guess I could now let's get the current state. Let's try to do so at the end will be a lift A2 of Alex try of first star and then slash. So if both of those return true, it means we've popped a star and a slash from the input stream. That means we are at the end of the comment. This lift end will apply the end inside the monadic action of apply this end on the result of both of those monadic actions. So we will get a true only if both of them popped the thing. However, if only one of them pop the thing, we still have modified the input stream, which is not what we want. So we need, in the case where it's not true, we need to restore the state as it was. So that's gonna be unless at the end put current state. We restore the state as it was. We ignore the changes we've made with this try. Okay, and we return the at the end boolean that tells us whether we are at the end. While not at the end of the comment, discard the current character. And discarding the current character is going to be just calling this get matching character and just ignoring the result, basically. And discarding current character is going to be void, so I ignore the result of get matching character, and the predicate is const true. We will pop any character we encounter. Okay, that should work. However, the problem here is at the end of this function, we are supposed to return the next token. And here, when we're done, we don't have a token. We've just finished skipping the comment. So we need to do something to get the next token, and that's the reason why I've moved Alex get next token to this function, is now we can just call Alex get next token that will call the thing again and might call the same action. If there are several comments in a row, they're all gonna be skipped. Okay, that should be all of it for comments. Now, we probably want to test this first. Yes, let's test. I can't test because all of the parser doesn't compile. Actually, maybe in JHCI I can try to compile some of the stuff and not all of it. For instance, if I do this, like a lot of things won't compile, but hopefully the Lexa itself does, which means if I do an Alex, no, it doesn't. Okay. This would be the Lexa. Ah, that still works. So Alex get next token. Huh. I imported the Lexa and I don't have that function. Okay, yeah, I think just the fact that it doesn't compile yet, I might be loading the previously compiled version. That's annoying. That means we're gonna have to delay all of that testing until we actually have fixed our parser. That's annoying. Maybe I should do that first then, rather than fixing more Lexa problems. Actually, maybe there's a compilation error in the Lexa. I haven't tried that. Yes, there is. Defined but not used location. Yes, that is correct. I don't need the location here. Maybe that's why. Defined but not used, current state. I don't... Why was I getting the current state if I don't need it? Oh, because I was planning to do this manually, but I did not do this manually. I used my Alex try and get matching character instead. So maybe that's why in stack GHCI it wasn't loading. It was because, yes, okay, we are back to getting parser errors. If I go back here, I reload, I import the Lexa. Do I have Alex get next token? I have Alex get next token. Okay, so we can try things in stack in GHCI, even if the project doesn't compile yet. That means the parsing function that I wanted to use is in a file that will not compile. That's fun. It is in this one. Yep, and it doesn't compile. Okay. That's fine, because I guess I could just, for the sake of having something temporarily, I could move this function. That's ugly. Yes, for the sake of debugging, for a second, let's do that. Let's move this function here, reload. Oops, not what I meant to do. Now I should have access to my debug lex function when I import the lexer again. I don't, so something is wrong compilation wise, probably because I didn't import the right things. Okay, so let's no, that looks fine. It compiles. So here, why doesn't it? Okay, now I have it. Perfect. So now I can try lexing things and see if they work. So now, if I call this, I'm gonna on an error just print the error on a success traverse print. Okay. And let's lex something. So let's try with something basic. We have a function named foo that doesn't have arguments, doesn't return anything, and it contains a const x equals 3. And debug lex is missing one argument. It's missing the name of the file, which is, I'm going to leave as the empty string. Okay, so we are lexing this as a function. Foo, open parentheses, close parentheses, open the braces, const x assign 3 semicolon, that's all correct. Now what happens if I add a comment with some stars and slashes and star in the middle until I have a closing comment here. And let's put a opening one even here. There we go. It is ignored properly. Perfect, because we do get x assign 3, despite the fact that we have this comment in the middle. Perfect. And if I put 2 slashes and a bunch of things here, nope, that didn't work. This is passed as operator div, operator div. Fascinating. So that's broken. That doesn't work. Oh, is it because this is not understood as a... Because this is longer. Or is it... No, maybe it's because it shouldn't be a string. I think that's what it is. So again. Nope, still wrong. But with the fact that the project doesn't compile, there's always a doubt of like, did it actually meaningfully change? That is annoying. Is it because the syntax of Alex is slightly different and this is not correct? That's a possibility. because this worked. This works for. Actually, have we tried this? Let's try this. If I say 0x 20 here, I do get 32. So this syntax here works. So that means there's something wrong with this one, because it should get the longest match, and instead it passes this as two div operators in a row, which means it matches. Where's the div operator? It matches this one instead of matching this one, while it's supposed to be always matching the longest match. So what's wrong with this syntax? Okay. So that looks like it's the correct syntax. No surprise there. So what's happening? Why is it? Oh, no, I was gonna say it's because I don't have a new line in my. Actually, it is a problem here. I don't have a new line in the string, which means I would not parse this correctly. I would be missing the closing brace if this were to lex properly. This would be correct. But for some reason, because this would match anything. Fascinating. I could re-implement it myself. It's not very difficult. I could just like make another like make comment function or something that just skips character until we meet a new line. But I'm kind of curious to understand why this doesn't work the way I expect. I mean, there's a possibility which is that we're not working with the correct version because of the compilation issues, but I don't think that's the case. Yeah, no. Oh, wait. Source file change. Are we just not looking at the correct version? Yeah, okay, that's what the issue. We're just looking at the not the correct version, because now with this version of the regex that works, we match the closing brace, and if I remove this, we just miss it. Okay, so no, that is correct. Okay, I'm relieved a tiny bit. So that's comment handled. I'm going to remove this debug lex that was only here because the parser doesn't compile. Now, there's another thing that we haven't handled, and that is my fault, I suppose. And again, the limitation is Alex only works byte per byte and doesn't have like built-in character class groups for some of the Unicode stuff. So we don't have a way to say match a Unicode letter, for instance. That's not a thing. So instead, to match identifiers, since identifiers can be any Unicode letter, we match any character, a dot, and we pass that as like, okay, it was nothing else. We encountered a character that is literally none of the other options in the language. It must be an identifier. So we try to pass it as an identifier. And if it fails to pass as an identifier, then we fail. We return an error. However, that there is a case that doesn't work with this. And that's the case where an identifier starts with a keyword. Because if I do this exact same thing, but instead of being x, it is function underscore x, which is a valid identifier, it is not the keyword function, this is going to be passed as the keyword function and the identifier underscore x. So that is broken. And I am not sure how to fix this because the problem is Alex will always take the longest match. So const will always be, or function will always be a longer match than just one character, which happens to be an identifier. So we need to be able to distinguish, to say those things only match if they are followed by something that breaks them, basically. So they must be followed by something that which is a symbol or a white space. And I think none of them can be, no, some of them can be followed by parentheses, I think. So I can't just say, oh, they must be followed by white space. But I could define, there's a syntax for this. Let me go back to the documentation. Actually, I shouldn't have removed my debugging function. I should put it back just because I'm gonna need it again for this. There you go. And there is a syntax for this, and I'm looking at, I want to define, there we go, I can define a regex ahead of time. So I can define something, which is, I'm gonna define it as keyword border. Is it an equal? It's an equal. And that's any white character, or it is any of the symbols, I think. And is that with... Yeah, I can make a reference to a symbol here, so I can say or symbol like this. And I can define symbols as the set of all the symbols that appear in the language, because that would be the valid things. Although most of the the keywords can only appear. Yes, but at the lexing phase, I don't know what the grammar of the language is. I should probably just match all of them. So a symbol is gonna be one of. Here's the list. Actually, yeah, maybe I should get it another way. If I do stack run, this is gonna work. I want to print the terminals of the grammar as it is described in this file. It might not work because the project doesn't compile. Yeah, okay. Okay, so let's take all of the symbols in this, and then we should really make the project compile because it's really, really annoying for us that it doesn't. So that's the list of our symbols. I'm gonna, I don't know, scratch, go here, go to a temporary buffer, remove all of the double, oops. Remove the double quotes, although we'll have to add them back because they are valid characters. So we want to have also those. Now I'm gonna delete matching characters. No. And this is gonna be, I'm gonna remove space and new line. Okay, so that's the list of all the symbols. Now, could I, let's do that in JHCI. That's the list of all of my symbols. Let's do a sort nub and sort of S. Yes, import data.list. There we go. This is a sorted list of symbols that we have in the language. So if I go back to this, the list of symbols is this thing. And I probably don't need to escape that. Okay. just hope that it's fine. Wait, there's a closing bracket here. I think it needs to be the first character if it appears in a... Note that special characters, lexical syntax for the list of special characters. Oh, well, that's basically the list here. Okay. So we probably need to just backslash all of them. That might be the easiest solution. The braces as well. Pipe probably as well. Dot, semicolon. It's basically all of them. What else? Dash. Parentheses. Star and plus, of course. Comma. I think that's all of them. No, this one as well. Okay. Hopefully that should be fine. And if it's not, Alex will probably tell us. Give me 1 second. Ah. 1 second. This is annoying. Oh, there we go. Okay, so now that should be fine. This is the list of all the symbols that appear in the language. We've escaped all the ones that are defined as special by Alex, so this should be fine. The end of a keyword is always either a white space character or a symbol as defined here. And now there is some syntax in Alex that I'm going to use, which is basically this needs to be followed by a keyword border. Otherwise, we don't match the keyword. Let's try. Let's see if Alex is happy with this. No, parse error. So there is an error here. So maybe this needs to be escape as well. This probably needs to be escaped as well then. Parse error on column 39. What is wrong here? Huh. If I remove this, does it work? It compiles. So there's that. So those characters, they don't pass. Okay, so I need to escape them as well. Okay, and now I'm just missing equals, I guess. Okay, now that this compiles. At least the Lexer does. So now, if we reload everything, wrong GHCI, this one, and import this, and try our debug lex function again. Where is it? There we go. So we are still parsing things properly. That's fine. Now, if we go back to our example with... I don't have it. Yes, there we go. Okay, and now this works. Now this works. We are passing this as the const keyword, which is here, followed by the identifier function underscore x, which worked. So here we now pass those keywords if they are followed by something which is either space or a symbol, basically. We don't allow anything else after a keyword. And otherwise, if there is something else, it means it's neither a symbol nor white space. So it must be a letter or anything else. And therefore, this must be an identifier. Reject this and try to pass it as an identifier. Okay. So now that's two of the big things we had missed fixed. Our identifiers are now like allowed a prefix that is the same as a keyword, and we handle comments. I'm just going to do one thing, which is I'm going to do this, which is not going to work on one line specifically, which is this one. Because viewed on a bigger screen, or rather a less zoomed screen, having everything vertically aligned will be nice. So it's very clear what is what. There we go. Okay. And with that, I think we fixed all of the things I wanted to fix in Alexa. I don't, again, there's the Unicode thing of like trying to have the exact colon count, but we're never going to have that. And I think if mainstream languages don't do better than when we do, I think it's okay for us to not like to count code points and count them as colons, basically. It's incorrect, but it's fine. It's actually, I think it's fine if we display the offensive string, like offending string in the error message, because it's like, oh, this is the part of the code that's wrong. If the column count is incorrect because of a Unicode string literal, I think that's fine. Okay, so let's start fixing our parser now. Actually, before we start writing the AST to fix the parser, there's a few things I wanted to fix in the parser as we have defined it. I wanted to change the syntax of the file a tiny bit and fix a few mistakes. So first, I wanted to make all of the keywords. I don't think I want to make them uppercase, but I think I want to make them surrounded in quotes, just that the name of the rule for the keyword will be the keyword between quotes to avoid collision with rules for non-terminals that happen to have the same name, because we had that bug last time and it was very confusing. So I think to make it very clear, if a name, we should be able to look at the grammar and be able to say this is a non-terminal rule or this is a terminal rule. So terminals should have something that differentiates them. For keywords, I think I'm just gonna surround them by double quotes, I think, like we did for operators. So this is gonna be at the beginning of a line, a series of non-space. And we're gonna replace that with, there we go. Oh, I missed this one. Okay, so now all of our rules are going to be wrong. We're going to have to fix this. And I think I'm going to change here to be closer to what we do in the grammar. I'm going to use for tokens that are not keywords nor operators, but are a special thing. I'm going to make them uppercase, basically. So this is going to be an int. This is going to be a character. And this is going to be a string. And likewise, identifier is gonna be, and you can go back to being underscore. There we go. So that means all of our grammar should be rewritten based on that, but it shouldn't be too monstrous. However, see, immediately this use is a keyword. Now it's obvious given the syntax. As is a keyword as well. This is an identifier uppercase. Actually, I'm just going to do identifier to identifier. Oops, that one is wrong. That's fine. Then let's go back to where we were. and look for the keywords. So type here is the keyword. Enum is the keyword. Struct is a keyword. Const is a keyword. That's the keyword as well. Block is not. That is a non-terminal. If is a keyword. Else is a keyword. Oh, in is also a keyword. Let what else we have? That's mostly it. So here is where we encounter our int string and true false, which are keywords. And now that should be basically all of it, because we're done with literals, we have done with identifiers, we're done with the yeah, there's only a few keywords left, I think. Expression as type as is a keyword, and that should be all of it, I think. Yep, that's all of it. Perfect. In theory. Now, let's try. Okay, so there's a few identifiers that are wrong, and there's a few types that are missing. Okay. Type here, okay. Aha. So that was a bug in our parser that this actually fixed. This here is a type expression. It's a type, like it's an actual type, not the keyword type. And it was interpreted as the keyword type because it was ambiguous. Now, with the keywords being in double quotes, we found an issue. So that's yeah. Here as well, this is a type expression, not a list between commas of the keyword type. So that's good news. Just doing this has already fixed a few bugs. That's good. And we have 3 identifiers that are left unchanged. Here, that is the identifier uppercase. And as identifier, there we go. That's the last one. Is there even a last one? There probably shouldn't be. Let's try. Okay. So now we've already fixed a few bugs just by doing this. So that's good. Our grammar is going to be easier to read now. But the other thing I wanted to do was to have a look at those shift reduce conflicts. And I know some of them are because I've forgotten a few things last time. So let's have a look at grammar.debug. Not pretty. We don't need that. So here's a list of all the states, the internal states of the parser that contain shift reduce conflicts. And if we scroll to one of them, for instance, let's go to state 136. So we enter this through all of those things. So some arithmetic expression followed by an expression. And then here's the list of possible keywords and the rules that apply. And if we encounter So shift using reduce using rule 87 is the problem. Rule 87 is trying to make us reduce, while otherwise it would like to shift. And if it's the one I'm thinking of, yep, rule 87 is the unary operator, not in this case, the Boolean one. But I think the negation one would also be a problem in some contexts if we look at other shift reduce conflicts. And the reason for this is I have made a mistake last time. I've defined this unary precedence, saying it's the one that binds the most, and I've used it here. A reference expression and a negation expression use this unary precedence. However, this is the wrong place to put this. So I'm going to remove this here. It needs to be on the actual thing, on the actual operator. There's going to be a problem. So it needs to be here on the reference operator, on the not operator. It is not Tiger. It's a project I've talked about on Discord that you may have seen. It's the compiler that takes a Rust-like kind of language and makes it into Piètre, which is a esoteric programming language that in which the source code is an image. For now, we're still at the parsing phase. We haven't even yet reached the AST, like defining the AST. We still have a long way to go before we generate images. But if you look at if you look on YouTube, if you look at the GitHub, there's a link to the YouTube. I've made a long video, 10-ish minutes video that explains the project and explains how Piètre works. And if you look at the logo of the project on GitHub, it is itself a Piètre program, which will give you an idea of how I'm gonna structure programs in Piètre. So that's the unary precedence set for the unary operators, which should reduce our shift reduce conflicts a bit, but not that much. However, the other thing I've forgotten last time, and that I'm just going to fix right now, here in our list of associativity and precedence, there's one I have missed, which is the lowest precedence, and it is the assignment operators. It's going to be equals, plus equal, minus equal, times equal, divide equal, power equal. Is there any other one? Do I have Boolean assignment operators in the language? Assignment. That's just an equal and compound assignments. Okay, I don't have the list here. If I go back to the list of operators, arithmetic, do I have? Range, assignment, compound assignment, that's the same list. Probably in the tokens then. No, I don't have the Boolean assignment operators. Okay. However, I do have one I had missed. I have the modulo assignment operator. There we go. Okay, so that's the ones I had missed. Those are actually not non-associative, they're right associative. And with those put in, this should significantly reduce the number. Yeah, there we go. 79 shift reduce conflicts. I hadn't looked any further, so I don't know what the remaining ones are. There's very few of them. Let's go to state. I think there's a few of them that are just like the use path, which is fine. But let's go to state 129. Ah, yes, and that I'm not sure how to handle, and that might be something we might have to debug later. Basically, the language is saying like, hey, if we encounter an identifier and then less than, is that the opening of a generic argument, or is that actually the comparison operator? And I think here the defaulting to shift, as in consuming more tokens and going further, is the right thing. We can't just reduce and say like, yeah, no, it is a less than. We can only make the decision later on with more tokens. So I think it's correct to just always shift here, which is the default in the shift reduce. I don't know what it is. Let's have a look. Oh, I should get into the habit. If I ever want to do an export on YouTube, I should read out loud the comments, because on YouTube the comments will not be there. So the question was that what's the font I'm using, and let's have a look. That is Déjà Vu Sans Mono Bold, at least here in the terminal. And in Emacs, it is. That'd be just in the init. Or do I have. Yes, there we go. It is just bitstream Vera Sans Mono. Yep. Yeah, just very basic fonts, but they're fairly readable. Sure thing. Okay, so I think at this point, the only shift reduce conflicts are left are things that I don't know how to debug, like purely with precedence, because like, yeah, the same operator is used for like comparison and for generic arguments. Unless we want to use some weird specific, like new characters for this, I think it will be fine. We're gonna have to test. So at this point, that's all I wanted to fix in the parser. We fixed the problem of the ambiguity of the keywords, and we found bugs thanks to it. So that's good. We fixed the precedence of unary operators, that's good, and we fixed the missing precedence for the assignment operators. Now, I think the only thing left to do is to make all of this compile by actually defining the AST, which we haven't done yet. So let's do that. As you can see, for now, the AST is a file is a list of units, and a declaration is just an enum. That was the very basic thing I had just to make everything compile. And I open the parser here on the side so I can see what I'm doing and compare with the grammar. So what do we want? A module. Let's start with this. Let's do a top-down approach for now, especially since it's the order in which the grammar file is written. So a module is gonna be a small record in which we have the use declarations, so the imports, because that's something that we don't need to keep past some of the early analysis phases. We don't need to keep that. Like, once the names are resolved, we don't need to keep the use things. So we probably want to put them separately from the rest of the declarations, which are gonna be. Let's make it a list for now. We probably want to use a better type of performance at some point later. But for now, to get started, this is probably fine, which is going to be a list of import. And we are going to want the declarations, which is going to be a list of declaration, which is to be defined. Two notes here. First, I am prefixing with the name of the type, because like those functions are just like those fields are just functions in the module in the same scope that, given a value of the type, extract the value. So if I define something like use declaration and there's more than one thing named that in the scope, the compiler will be confused because it will not know to which type this field maps. There is a language extension to allow different types to have the same field name, but as a convention, prefixing with the name of the type is fairly common, and I'm using underscore because I will be generating lenses at some point. However, there is something I've been meaning to do that I haven't done here, which is I'm going to be using an approach that's been described in a 2017, I think, paper called Trees That Grow, which is basically I'm going to use the same AST at different stages of the compilation. because we're gonna get the raw parsed AST, then we're gonna do like analysis, we're gonna do name resolution, we're gonna do type checking, and so on. And every time we do that, we're gonna be both removing some things we no longer need and adding in new information that's relevant for like how we generate the IR from this. And as a result, I'm gonna be changing the shape of like changing data in the AST, but the shape will remain the same. And rather than having like a set of types per set of stage of the AST, I can use the same types, but have them configurable in a sense. And we're going to do that. We're going to do exactly that. And this is going to be done with, I'm going to do some magic here. I'm going to make an enum called AST phase, which tells me what stage what phase the AST is in, which is going to be parsed for now. And there's no, this, depending on how we do the analysis, there might be like renamed, type checked, whatever, like the name of the different, like the type of the different phases. That's just an enum. What I'm going to do, however, is I'm going to make a class, which is going to be the, how do I call this? I think it's usually the types are called X something. There's type families. Grouping it in a class is not the way the paper was written. I just find it convenient for other things. AST representation, let's say that, which is going to be a class that is not a property of a type. This is where, okay, we're doing some magic here. It's going to be fun. The thing on which this applies is an AST phase. And here we're going to list the list of types we want to associate. So for now, there's nothing. I'm going to do it later. And here, the module will be parameterized by the AST phase. The import will be parameterized with the AST phase, and the declaration will be parameterized by the AST phase as well. Yeah, I'm still not completely sure what I'm gonna do in terms of treatment of the AST. The obvious things are like name resolution and type checking, but I don't know how much AST rewrite I want to do. That's something I need to think about for next stream or for the stream after the one where we're done with the parser, if it's not this one. I am not entirely sure there yet. I want to do most of the optimizations on the IR rather than on the AST, because it's a lot easier to do like control flow analysis on the IR, like removing redundant computations, doing constant folding. All that stuff is a lot easier to do on the IR. So for now, my plan is for the optimization phase to be on the IR, not on the AST. I'll see if there are things that make sense on the AST, and if yes, I'll add additional phases there. That's something that's still unclear. I need to think about it for when we approach that part of the project. Yes, the thing I wanted to do is at some point here we'll have the thing. We're gonna have something that says, well, for the past phase of the AST, here's the representation. And here's where we're going to list the list of types that we actually need. But now there's nothing. We'll get to this magic in a bit. So for now, every type in my AST will be parameterized by this thing, which is an enum that tells we're currently in the past state, or we're in the resolve state, or whatever it is. For now, past is the only thing that we care about. Okay, so a module is a list of imports and a list of declarations, and I think that's about it, because a module here is just a list of declarations. Some of them happen to be imports, and I want to treat them separately just because it's convenient for me. Okay. I guess I could simplify this already. I could make my module type an instance of a semigroup and monoid. Can it do that automatically for me? Can I do a deriving semigroup monoid using the fact that both fields are semigroup and monoids? or will it require some information about the p parameter to be able to do that? We'll see. Because the idea being, semigroup is just there is a way to combine those things in a way that's non-commutative but associative, and monoid is that plus there's a default element. Both elements are lists. The way to combine two elements of type module is to do the concatenation of the list within, and the empty element for the monoid is empty list. Because this would make doing this a lot easier. Because now I can do, given a list of declaration here, this is gonna be, I get a list of declarations. How do I make a module out of it? That's a mconcat using the monoid property. And here, kinda just fmaps. It's gonna be a tiny bit more than that because we're probably gonna do traversal of the tree, especially if we do rewriting. It's not just gonna be an fmap because we're gonna be replacing forms of the AST with other forms of the AST. But otherwise, yes, it's gonna be mostly that kind of thing. It's gonna be a traversal of the AST, maybe written manually, maybe a traverse rather than fmap, to actually go at each point that's interesting, do a local computation, output a new result, and replace the AST by the new version. Like renaming, for instance, name resolution, for instance. And type checking is mostly going to be that. And I don't know yet what representation we're going to need. But for type checking, maybe we persist some type information. So when we change the type of the AST to contain the type of the expression that we have inferred, and we remove the old thing that we don't need. But also, we need to do that in a monadic way so that we can return an error in case the type checking fails. We'll get there when we get there. For now, let's finish parsing because we don't even have an AST on which to do traversal yet. But yeah, the idea with this is if it's a monoid, I can just get a module from a list of declarations by using the monoid property, just an mconcat. And that means declarations is just many declaration. And maybe I could remove this grammar rule and just say, this is many declaration, and I don't need this. And a declaration is it gives me a module, and in the case of a use declaration, I'm gonna create a module with this thing here, and in the case of the others, I'm gonna do module and put the thing we have passed, the declaration we have passed, in here. Okay, that should be fine. So now, what is an import? I guess an import is always a path. It's always a path, optionally a use alias, and optionally a list of the things we are importing. Okay. So it's actually a use declare. I call them import because I'm used to Haskell. In the language, since I've based the language reparsing on Rust, they should be called use declarations. I call them import just out of habit. Let's keep it import. It's fine. So it's gonna be an import path, which is gonna be a list of identifier. And there's gonna be either we have a star that means import everything, or we have a list of identifiers to import, or we have an alias under which the path should be imported. But we can never have more than one of those in an import statement. That suggests that it should be one type that is a enum with all three cases. How do we call that? Import type, I guess? Which is just gonna be an import type. Maybe we won't need the phase parameter on all of those things. We'll see. And an import type is going to be qualified, and that takes an identifier, or specific, which is going to take a list of identifiers, or it's going to be exhaustive, which doesn't take a list, an argument at all. It's just like we're trying to import everything. Okay. Yeah, I think for now, I'm not going to put the phase parameter everywhere for the import. We don't need that yet. This is the way we're going to approach this. For now, we don't need it, I think. Actually, I think since for now we're trying to make the parsing compile so that we have a project that compiles so we can test things, I think for now, all of this I'm going to set aside, and we'll get back to it when we've finished parsing the AST, I think. I don't know. I'm of two minds about it. Maybe I should actually do it from the start so that we don't have to modify anything afterwards. Nah, let's do it for now. Look at this for now. Okay, so here, this is an import. So when we encounter this, the use path will be a list of identifiers. So that's the first argument to our import. So this is always going to be import $1, because we always put the use path first. And here, this is going to be with exhaustive. Here, this is going to be with $4, which is the list of identifiers. This is going to be, oh no, actually, we probably want the parsed phase immediately, because one thing that we're going to have everywhere at first that we're going to discard very quickly is we're going to have location information, because for now every token gives us the location, and that's very useful for error messages, but we probably want to discard that at some point. So that's probably something we will want to store as an extension type. Okay, so here this is a list of identifiers, so that's $4, I guess, which is gonna be our specific. And here we have, but it's only, I guess the alias is optional, so that's a maybe identifier. But we probably want to treat this as a common case, because basically that means none of the symbols are imported in scope. This is just that they have to be used, and maybe that name can be used instead. Yeah. Okay, so let's do that. And this is the second thing is going to give us. So that is well, it's happy, which is a Haskell version of yak or bison. Basically, I'm using, since this even though this project is like a toy compiler for a made-up language that goes into an esoteric language, I'm approaching this as if it were a real serious compiler that's going to like actually be used. So I'm using the standard tools as much as I can, which is why even though Alex, which is the Haskell equivalent of Lex or Flex, has been extremely annoying to work with so far, it is the tool that GHC uses to parse Haskell. It is the standard tool for compilers. Therefore, it's the one I'm using for this project. So yeah, we're using Lex. We're using Alex and Happy. So the Haskell equivalents of Lex and Yak, or Flex and Bison. So yeah, this is Yak/Bison here on the left. But the difference here is between the braces here, this is actually Haskell code. And there's a few extensions to it that are Haskell specific as well. Like for instance, some of the parameters of the parser are how to call the Lexa directly, and this is I'm fairly confident the percent monad is not a thing that exists in the original Yak. But basically, this is how I'm telling Happy to call the parser underneath. So we don't call the parser on the entire file and get a list of tokens, and then call Alexa on the entire file to get a list of tokens, and then call the parser on the list of tokens. We call the parser, then every time it needs to do a shift and get the next token, it calls Alexa to just get the next token from the input stream, which means we only go through the entire source file once. And we don't create a list of tokens that is just like consumed once, basically. Although with list fusion, the compiler might be able to not, if I were to lex everything and then run the parser, the compiler might be able to optimize that, but it's easier to do it that way. So here this is qualified, and this is a maybe value, which is the second thing we match here, which is this one. It doesn't, as far as I know. I think the only thing, I mean, we are look ahead one. This like the Yak generates, well, Happy generates a LA1, I think. So we have one look ahead. I don't. The only thing that we have left in the shift reduce conflicts after the changes we've made today is the fact that the generic argument operators is the same as less than, and that's it gets confused because of that. Otherwise, I think the grammar is mostly unambiguous. We had like we're down to 79 shift reduce conflicts for the entire grammar. I don't know how bad it's gonna be. We're gonna have to test. Okay, so that's it. We have here. So $1 here is going to be this thing. So it's a use path. So it's a little identifiers. This is the maybe the use alias. So that's this. Okay. So that's our imports done. Use alias is an identifier. That's fine. Use path is a list of identifier. That's correct. Yeah, I think all of this is correct. So now we can move on to declarations. Nah, I'm just going to put it back, I think. So what do we have? We have three kinds of declarations, I think. We have type declaration, function declaration, and constant declaration. And maybe I could here like remove one layer and have every declaration listed here so that we have like every symbol that is exported is directly a declaration constructor. So that would be a type alias. That would be an enum. That would be a struct. That would be a constant. Or that would be a function. And this is where I think we're going to start using the AST phase, because here, let's go with the extremely verbose version, and we are going to simplify later if needed. So this is going to be an X type alias. It's going to be an X enum declaration. Oh, I need to put the declaration here. Extract xconst and x function, which are going to be type families, so something that associates a type to another type. So here we're going to have type I'm going to copy this. So basically, what is the type that we associate to a type alias declaration in the given phase P? And so I'm going to go back to putting this everywhere, at least on declarations for now. And for now, what we're going to want to store as the result of a pass, actually, just going to copy this, I need it. For now, I think the only thing we need is the location. Okay. So now here, when we are in the past phase, which we're going to be here, because that's what this is going to be outputting the past version of those things. We're going to be storing the location information. That means, however, we're going to need to figure out a way when we pass in the parser, we're going to have to make sure we have a way of outputting the actually, I think at this point, all of those things are just going to return the declaration directly, which means I don't have to surface it. Maybe I'm going to do the same thing. I'm going to remove this in... I'm going to inline this in the same way that I'm inlining everything else. So rather than having a type declaration, which is one of those things, I'm inlining it. Oops. Okay, there we go. Syntax highlighting doing some weird things here. Okay, now, so this alias declaration is going to be a declaration parsed. So is going to be an enum declaration. So is going to be a struct declaration. And here I can access the location information. I'm going to change something in all of the keywords and the operators. The value as far as the parser is concerned is going to be, for all of them all the way here, it is going to be the location. Okay. Okay. This is wrong. This is an identifier. The Haskell type. There we go. Okay, now let's go back to our declarations. Do I make a new record for each declaration, or are some of them just fine on their own? Like maybe a type alias doesn't require... Maybe it's easier to just have a record for everything. Yeah, maybe I'll do that. So this is going to be a type alias P, and here is going to be, I'm just going to copy all of this. Okay. So what is a type declaration? A type alias. Type alias should be the easy one. What is it going to be? It's just the name of the identifier. Oh, actually, maybe in the module, maybe I should not list declaration as a list. Maybe declarations are actually a hash map from identifier to definition. Because the order doesn't matter, especially since we're not trying to make an AST that preserves the source code, because we're not trying to do like to expose this as a library for source transformation purposes. And having the thing as a hash map means we can fairly easily use our type level shenanigans and trees that grow approach to then basically make the final representation of the AST one in which there is only the hash map of declarations, which is basically the symbols. That feels like a good idea. I don't see the downside. I see one downside. I see one downside, which is that here I would have not that I mean fully qualified names will be to call something, yes, but when I export something out of the module, the name of under which the thing will appear in the export list will be the name, the identifier that appears in the type declaration. So could I just save some time and rather than having each declaration contain a field which is, hey, what's the name of that thing? What's the identifier by which it is declared? Have this already surfaced as a hash map at the module level. I think the only downside of this is I would need to change my parser to resurface that, and I probably don't want to do that. Because here, the constant declaration would need to return something. It could return a tuple of like identifier and definition. And that way, yeah, actually, that feels doable. That feels doable, and therefore I don't see the problem with that, and I think I'm gonna do that. So here, rather than using a declaration, I'm gonna use a hash map of identifier to declaration. This doesn't change anything for our monoid thing because hash maps are monoids under union. Like the empty value is the empty hash map, the concatenation operation is the union of hash maps, so it works just fine. Oh, no, it doesn't work. It doesn't work because if we do that, we're gonna erase the fact, like if two things are declared with the same name, we're gonna silently accept it. No, we need to do the exporting at the end. We need to create the hash map when we have validated that all the names are correct and all the things are correct. Nope, we can't do that. Okay, so I stand corrected. Because yeah, otherwise we would just not detect the collision at all at passing time. And we were just like, yeah, no, whatever name thing foo, if there's one name foo, is the latest one that appeared in the hash map or the first one that appeared in the hash map, which is not correct. Okay, so we don't do that. So that means that a type alias is going to be a struct that contains the name, which is an identifier, and it contains, what's the only thing that it contains? It contains optional generic parameters. For now, do we skip that for the sake of having something that compiles first without dealing with the complication of generic parameters? No, I think we might as well just handle it. Because at this point, we're not checking that they're valid or anything like that. Well, checking that they're valid in this case would be checking that the types that appear here appear in the type expression afterwards. But we don't need to check that for now. So for now, yeah, I think so. I'll have to think more about it for next time. For now, I'm focusing on parsing, but yeah, I think it's the rewrite is the right thing to do here. Okay, so we're gonna just store the generic parameters, which is a type that hasn't been defined yet. That's fine. We continue with the top-down approach, and then I guess alias value is a proper name for that field. This is gonna be a type expression. And here's something where there's going to be some checking required. Okay. Next, an enum declaration should be easy. Oh. Let's be consistent. Type alias dec is the constructor, and type alias is the name of the type. So this is an enum. And an enum is the name and the list of identifiers. That's all. Do we want to store that as something smarter than a list? No, the order. I was gonna say a hash set, but the order matters for now. Let's just keep it as a list. We can already do a tiny bit of work here. So this is what is this? So this will create a type alias declaration. The first parameter will be the location, which happens to be $1, the value returned by the type token match, type keyword token match. Then we need to return a type alias, the name of which is going to be $2, this identifier. The generic values, the generic parameters is going to be, it's going to be a maybe generic parameters. There might be a way to collapse that. Like maybe generic parameters is a type that has a default. Like it's a hash map or a list or something. Yeah, I'm probably gonna make some function here. How do I want to do this? I guess I could introduce something. Yeah, I think I would rather introduce. I would rather avoid typing a bunch of code in this, basically, because I want to keep it readable. So I think typing a from maybe empty list or something strikes me as inelegant. So maybe I could do something a bit smarter. Like defining a function here and then call that. What's the best course of action here? Or do I want to define a custom optional generic params which call the optional thing and does the default? This might actually be the right approach. I change this to be optional generic params. Ah, this feels ugly. Oh, I could do something smarter. Yeah, let's do that. What's the property I'm looking for? Actually, I'm gonna not look it in JHC, I'm gonna look it in Google. Or even I want to have a look at monoid. Oh, wrong link, that's fine. There is probably a way, a function to just put a value in a monoid, since monoid has both the notion of an empty value and concatenation. So there's probably some kind of like not singleton or something, like a unique thing inside a well, pure, I guess, but pure is not, that's for applicatives, not for monoids necessarily. Actually, Google to the rescue. Given a monoid M, some value A, well, some value. Ah, that doesn't make sense because monoid is a property of the containers and not. Would that be something infoldable? Because foldables are related to monoids in a way. No, I don't think there is. I think applicative is actually, or alternative is what I'm actually looking for. So basically, what I was thinking is of doing is doing, instead of saying optional does nothing in case the thing isn't there, or just the thing when it's there, doing pure and MMT basically, which will work for a bunch of types. It will work for list. It will work for hash maps. No, hash maps, it won't work. I think because hash maps are not applicatives. Although I guess I could put it in a first and then. Yeah, not an applicative. But there are lists, so I could make it as a Let me think for a second. Is there an elegant solution to this problem? Because what I require is the result to be some kind of monoid. It needs to have the notion of an empty value. Which is fine. That's the case of nothing. It's the case of list. It's the case of hash map. So it's the case for most of them. Is there a way, however, to put something in it in a way that is generic and that works for any of them? What's the constraint I want here? Because pure requires applicative, which hash maps don't have. I don't think there is a good notion that I'm looking for. Okay, so I think hash maps just don't work with this. That's fine. Oh, unless the element itself is a monoid, in which case. No, it doesn't work. Yeah, no. Okay. So I think this is fine. And the upside here, if we go back to what I was trying to do and why I was doing this detour, is if we go back to optional generic params, as long as this type is both a monoid and an applicative over the list of the generic parameters, then that doesn't work. That doesn't work. Because I'm doing a pure on. No, that doesn't work. Okay. I'm sure there's a way to do this. I'll have to think about it. Because, like, this only works if the thing itself is a some kind of monoid and has a default empty value, which is not going to be the case in a lot. Like for a list, for maybe that would work. Yeah, okay. I'm not going to bother. For now, let's keep this version. For now, let's do the verbose version, and I'll think about it and see if there's a way to express this in a way that's a bit more convenient. But also, I'll look at it depending on how I end up using my optionals, because maybe 90% of them are just really a maybe, and there is no need to try to make a generic thing that handles all kinds of optional things in a nice way. Okay, so here, this is going to be some kind of like from maybe an empty, probably, which I think is a fold. That's true only. Yes, that's true if the thing is a monoid, which if it is, I'm using MMT, it is. That means if I have a maybe of a list, then fold of a list of string who will give me the list of the string foo. Yeah, and if I have, well, actually, if I have just the list of string foobar, I get it. If I have nothing, I should be getting the empty list. Yeah, that's a fold. Okay. So fold actually is probably good enough. And that's what I wanted. That's going to be $3. Our generic parameters, we're going to fold them, assuming they have some kind of monoid instance underneath. And our fourth parameter is going to be, sorry, our value here, a third parameter here, but the fourth thing we're going to extract here is going to be the type expression, which we are going to get from the type expression there. So this is just going to be 1, 2, 3, 4, 5. That's just $5. Just. Okay. Next. Enum we already have, so it's going to be, I think it's going to be a fold there as well. We just want to do, we're going to have a maybe list, and we just want the empty list if there's nothing. So it's going to be the same thing. Yeah, I think fold on the result is what I wanted. So this is going to be a declaration, which is going to be an enum declaration. The location is going to be $1. And the actual enum declaration is going to be an enum with the name, so $2, likewise. And the values are going to be fold of $4. This thing. Okay. An enum item is just an identifier. Ah, yes, I wanted to have this rule, which is just an enum item is an identifier and nothing else, because I need to do some translation here. So it's going to be, because here, when I match the identifier, I get a tuple of the location and the actual token. And I have no clean way of extracting one and without the other in the syntax of happy. So I'm going to need to do some kind of function on that. And here I think it's going to be a discard location basically. So get raw identifier, which is a function that I'm going to have to include there at the end. So that's something that's going to take a location and a token. I'm going to return an identifier. I am not in my parser monad, so I don't have proper error handling. And that means that here the only thing I have available to me is a panic, but I think that's fine because if there it is impossible for this to be wrong because the user typed something wrong. If something is wrong, it's because we typed something wrong. Because we should only call this when we have matched an identifier token and never otherwise. And as long as that assertion holds, then we will be fine. It's a bit annoying to have to do this because here location that we discard actually. The syntax highlighting being wrong in happy files is very annoying. And a token. Here we are gonna have to do a case on a token of the identifier and return the identifier. Because we matched on it, but we couldn't extract the value at time of matching without discarding the location. And in a lot of time, we will need the location. So we return the tuple, but with the unpassed token in it. And therefore, we have to redo a case on it to get the identifier, despite the fact that we have already asserted that it is an identifier. That is a bit ugly. And that means here we have an error case of like, I don't have yet a proper like ICE for my declaration something, but like that's basically not an identifier. And we can do at some point one evening a session on like having proper error messages, because that's not a very good error message. Okay. Let's go back. Don't think we're gonna finish the pasta this evening. So here we are getting, oh, actually here identifier, I need to do a get raw identifier from $2. And here I need to do it from $1. Okay. Now onwards to structure. So a structure has a name and a list of fields, which is just there. Well, I'm not going to do a hash map just yet because, again, we need to do a compilation phase of validating that it is correct, as in not all, like, no names can be repeated, that kind of stuff. Maybe there could be a good use for the type extension thing, where the type of a struct field depends on the phase. When we have resolved that they're correct, it can be a hash map instead. For now. For now, this is just a list. So that's a list of tuple of pairs of identifier and type, I guess. So type expression. We do the same thing here for a structure that we've done before. So for a field, we get the identifier, we discard the location. Is that good? Do we want to discard the location there? We probably want to keep it, actually. But maybe we keep it for the type. Or maybe it's enough to have the location of the struct and for the error message to read like in structure foo at in file x at line 364 or whatever. Two fields cannot be the same, and it's okay if the field names are not listed. The lines and columns of the fields themselves are not listed in the error message. Probably fine. Definitely fine for this evening. Okay, so a structure declaration is gonna be the same thing there again. We do a struct dec, we call the constructor. Our first argument is the location, which is given to us by the token. And the second argument is a struct, which contains the name, which is $2. Oh, there again, identifier. I need to call the get row identifier. I need to call it in a few places. Here. This is not very readable with the screen being that zoomed. Hopefully on GitHub it's going to be a bit more readable. For now, a location is more than that. It is file name, address, which is the index in the source path. So that regardless of column counting, because again, column counting is weird as we were discussing earlier because of Unicode code points not always necessarily being one column. Yeah, basically the address is the index in the source file and line column for error purposes. I am kind of tempted to see if I want to include like the current line as well, just like if I want to include the range, as in how big is this particular location, so that we can do some more complicated things, like this struct goes from this location to this location, which would allow for better error messages because I could extract the whole text of the struct and put it in the error message, and do the thing that Rust does with like underlining the exact thing that is wrong. Or maybe I just need the current line and I just like keep a copy of the line in the location. I'm not sure yet. For now, this is what the location is. And yeah, this is our very wrong update location, which ignores yeah, span probably better. Line colon is I mean, this is line colon is what GHC does for Haskell. So it's not a bad approach. It's just it is not as good an approach as a span for sure. But as always, we're gonna make incremental progress. For now, we have line colon. It gives us some subpar error messages. At some point, we'll probably refine a tiny bit to make better error messages. What I was doing calling get raw identifier for the type declarations. Yes, that's done. That's done here too. And the only thing I'm missing here is for my structure, I need my struct field, which is this list, and that is the 4, 1, 2. Oh, generic parameters. I forgot the generic parameters. Yeah, of course. If I have a span, I can recover line columns for sure. For now, this is the simplest thing to do. So for now, this is good enough. But yeah, I absolutely agree. A span would be better. Okay, so generic parameters there again, which means here I need to fold them as the second argument to my structure. And then the last argument is the values, which is the list here, which is 1, 2, 3, 4, 5. Which means here, this is going to be a list of tuple, identifier, and type expression. Wait, no. One field is just a pair, identifier type expression. There we go. And here I'm calling comma list of struct field, which is going to make me a list of all the things that matched, which is that. Okay. So now we're done with 3 out of the 3 type declarations. We're missing the constant declarations and then function declarations, which will segue into statements, which will segue into expressions. We've been at this for 2 hours. I don't think I'm gonna finish this evening with the parser. I think I'll do 1 more hour, I think. And in 1 hour, I'll try to debug what we have already written, see what compiles, see what doesn't. And I'll probably stop there for the evening. I'll probably do a second stream this week. So my plan moving forward is to do every Tuesday, and on most weeks the Thursday as well. It's just I'm not sure that I will be able to do the Thursday every week, but I think this week I'll be able to do it. I'll put it in the Twitch calendar. I haven't done that yet. And my plan in terms of what to do next, I am tempted when I'm done with like the AST, when we have something that passes and we can pass the AST, I want to take a first break to write some tests because we'll have something we can test. The downside will be tying the test to the shape of the AST as it is after this first draft, which might change, which means we're going to have tests that are going to be a bit annoying to maintain, but I think it's still going to be good to have them. And I think I might take a break and go do something that's unrelated and do the other side of the compiler, as in the image generation part, the bytecode and the image generation, because it's going to be a lot easier and it's going to be a nice break to do something a bit less like verbose and complicated and just do some image generation so that we can already try writing manually some bytecode and generate some Pete images. So I think, yeah, I finish passing the AST, we write some tests, I go do a week or 2 of break on the bytecode and the image generation, and then we get back to the actual compiler thing where we do all the lowering into the AR and like all the analysis and the lowering into the AR. This is not an official plan. It might change based on mood and how I feel about it. What's my battery level? Okay, still good. Okay, so that's our structure. Constant is going to be fairly easy. What do we have? We have a const name, which is an identifier, as always. We have a const type. Yes, that's a good point, and that's probably the right way to test this. The downside I see, well, I guess it doesn't matter that it's not exactly the same thing as the input source file, and we discard like white space and comments, because after all, it doesn't have to be the same for the purpose of testing. Yeah, you might be right. I think well. No, I was gonna say the downside is there are things we might not be able to test with pretty printing, but if we parenthesize every single expression, we can test the parity parsing like that. So it's probably a good idea. I think pretty printing it might be the right way to test this, to avoid tying the test to the implementation, which might change. I think you're right. Yeah. The more I think about it, the more I think you're right. That's the right approach. And there isn't a lot of things that we can't test with that method, as long as we include everything we need in the pretty printing. Because it doesn't have it doesn't have to be actual codes that would be passed back. I could pretty print in a way that is slightly different if needed for the purpose of testing, of course. So we need the type, which is a type expression, and we need the expression. I think that's it, which means here we can go back and do the same thing. This is a const declaration at location $1, and its value is a const in which the first argument is the name, which is get raw identifier of $2, and the second is the type expression, which is 123.4.4, and the expression is 123.456.6. There we go. So that's our constant declaration, and that is also a declaration passed. Now, a function. What is a function? A function is going to be name, identifier. It's going to have some generic parameters. I don't think I'll handle generic arguments and generic functions in the first iteration of the actual compile phase, just because there's like Pete is so limited, it's going to be a nightmare to have things like this. So I think I might do a first. I think I'll do a first like compilation lower into AR generate bytecode version that only has int basically, and then I'll go back and extend to have strings, vectors, maybe generic parameters, and so on, because it's going to be a lot of work. No lifetime tags. No, I mean Pete doesn't have a heap, so everything has to be on a stack, which means vectors or like strings or anything that is dynamically sized, that's not a pointer on the stack that points to the heap. It is the whole thing as several elements on the stack. So that's gonna be a nightmare to implement. My current plan for implementation for things like this is basically I'm gonna need to have for any type that has a dynamic size, I'm gonna need to have the first stack element be its size so that I know how to access a specific element by doing the sum of the sizes, so I know how much I need to rotate my stack to get to the thing I need. It's gonna be There's going to be some challenges with the fact that we're dealing with a esoteric language that doesn't have a heap and very limited stack operations. But that's half the fun. But yeah, as a result, no lifetime annotations, nothing like this. The fact that I'm already thinking about doing generic arguments, that's already going to be fairly complicated, I think. But that's part of the fun. I want the arguments. What my argument's going to be? I think I'm going to make a separate type for them. And then we have, I guess the type is optional. And then we have the body, which is going to be a block. I might... Yeah, I don't think I'm going to create a special type for a function body, and I'm just going to reuse block, because block is going to be... Yeah, I think so. Well, it's a list of tuple. The only thing is that, is there anything... No, there isn't anything special. And I did not do a special type for... I didn't do anything special for the fields of a struct. Maybe I should not do anything special for the arguments of a function. At least for now, maybe this is good enough. Okay. Okay, let's do that. So let's go back here. And let's copy this because it's going to be basically sensibly the same thing again. This is going to be a function dec at location $1, which is given to us by the token here. And the content is a function. We get the identifier with this. The generic parameter, the generic arguments 3, the arguments 5, the return 7, and the block of statements 8. There we go. Function argument is going to be the same thing. Oh, actually, this is a declaration passed. A function argument is there again, the same thing as a field here. To the point that I could consider reusing the same. I could introduce, just say, a gamma rule that is the same in both cases. I wonder if like having the exact same thing of like identifier followed by colon followed by something else, like two rules which are exactly the same but have different names based on which context they appear. I wonder how much of that actually contributes to shift and reduce conflicts. Probably not, because whether I'm within a struct declaration or within a function declaration is pretty obvious from context. So this is probably fine. Could be worth thinking about deduplicating this, basically having like a grammar rule which is like comma separated list of identifier column type expression. Oh nope, I'm wrong. Haha, that's fun. The type of a function can be different. There is one thing in the language that I have made that is different. Since there's no heap, there's no pointers, except for one thing. I have kept the reference syntax because I want to be able to say at a function call site that the type of like this function takes this parameter by reference. And what that means basically is rather than duplicating the stack value of that type to put it on top of the stack to call the function, actually just move the actual value to the top of the stack and use that for the function. Because that way it avoids like a bunch of deep copy of a bunch of things. It's not exactly a passing by pointer, it's really just like rotating the stack to move the actual value. But as a result, reference can appear in a function archetype, which it cannot in a regular type. So this is not a type expression. This is... I guess it's a function? Archetype? Function... do I need that, or can I just... like, is this just a type plus a Boolean information, basically? Yeah, I think that's what it is. I might not need just a full dedicated function archetype. I can maybe just say instead the value here is... it's a tuple of three things: identifier, function, like type expression, and Boolean. And that Boolean is whether that thing is given by reference or not, basically. That's probably enough. Except... yeah, that's probably fine. But that means, however, that here for the function argument, this needs to return three things. It needs to return here the boolean as well. That means I might need to decompose this. So this is going to be a tuple which contains get raw identifier $1. It contains first of $2 and second of $2. There we go. Oh, 3 rather. And then this function archetype is a type expression passed and a boolean. And if it's a reference, yeah, that's just gonna be $2. This is a type expression passed. So that means here I get $1 and false. And here I get $1 and true. Okay, not very elegant. Yeah, I'm not sure. I think you're right. I think you're right. It's better than the boolean. Just to have something a bit more elegant. It's isomorphic to a boolean, but yeah. No, I think you're right. I think you're right. Okay. Let's do things in a clean way. Function archetype. And that's either a by value that is a type, takes a type expression, or it's by reference. And now this is a function archetype. Yeah, I think you're right. That's better. Come to think of it, is there any way there's going to be something different at some point? No, I don't think it's going to change ever. But that being said, maybe I'll resolve to like. Nah, this is better. It is better also because, yeah, perhaps. It is also better because that way the type is one value, and if I want to make a hash map of this, of like, A, of the name, what is that type, then I have an actual value rather than having a tuple. There again, then I would have the decompose, recompose. So this is definitely better. So this is now a by value and a by reference. Which means this is no longer this is a function archetype parsed. There we go. And this is just $3 now. Okay. A return type is just a type expression passed. And that's $2. Okay. Do we do generic arguments now? Generic parameters are just names. Yeah, I guess at this point there's nothing else than type. That's not never gonna change. I'm never gonna have things more complicated than like the parameter to this thing is a type t. I'm not gonna have. I said that now. I hope I don't come to regret it. I am not gonna have type level computations in this language. Function pointers. That's a good point. But I think if I have function pointers, I might just give them with the same. I don't have function pointers at all in the language at the moment. I don't have a way to give. I don't support. I don't plan on supporting reference to functions. It should be doable in the sense that what I'm planning to do in the Piètre translation is basically each function gets a unique address. So I could just make something that when I do the linking kinda and assign an address to each function, replace every instance of like, hey, I'm getting the reference of this function, replace that by the int value of the address. But that's not something I'm planning to do at the moment. And even if I do, I guess it would be the difference would be allowing the reference expression to be used in an expression context to get the reference of something, and the only thing you could take a reference of would be functions, and then the type argument of functions would be the same. You're still giving a value by reference or by value, and that value happens to be a int which represents the function address. So I don't think this is going to change meaningfully in any way. But I still think you were right. Not using a boolean was cleaner. But I don't think, yeah, function reference is something that I'm thinking of doing at some point, but I don't think it's something that I want to do just yet. Also, there's a few things like this that like I have left out of the reference of the language at the moment, because not because I think they're gonna be super hard to implement, but because I think they're gonna be interesting to implement when everything else is already implemented. As in, how do we go about implementing this not in something we make from scratch, but in a project that already exists? How do we extend a compiler, basically? Having to do this when everything already exists and making sure we don't break anything. An example of this is tuples. There is no support for tuple syntax at all in the language at the moment. That's something I'm planning to add at a later point. And there was another example of something like I think pointing to functions was, well, function references was something I had in mind. Was there something else I was thinking of maybe adding at some point? I don't remember. Like there's a few things like this and are not in the language at the moment that I'm thinking could be interesting to add as extensions once everything else already works. Okay, what am I missing? Basically, the way I'm thinking about reference arguments, the way I'm doing it, when I manually write Piètre function like Piètre programs at the moment, I basically push all of the arguments to a function, then push on top of the stack the address to the function, do a goto basically, which like pops the value of the function and redirects the execution to that place in the image. What I'm thinking of doing is basically if a function has a reference argument, like basically the shape of the stack when I return from the function, I expect to be the return value of the function on top of what I had before pushing the arguments, basically. And if there is any argument that is by reference, I'm expecting them to be there in the stack as well. So there's going to be basically what the shape of the stack is. They're going to be passed on the stack. All arguments are passed on the stack because there's only a stack. The question is if they're by reference, they're moved to the top of the stack rather than copied to the top of the stack. And if they are passed by reference, when the function returns, I expect them to still be on the stack when the other arguments will have been popped, basically. That's the gist of it. I have not formally written that anywhere, but that's the idea. And I think that should cover most cases. The only difficult thing, well, the only difficult thing, there's many difficult things, but basically what we're going to have to do is when we translate the IR into bytecode, we're gonna have to do basically register allocation, except we don't have registers, so it's all gonna be all spilling to the stack. But basically, like, okay, where is everything on the stack? How do we move things on the stack? And one thing we're gonna have to do at this point is like, okay, I'm calling this function. I have to copy thing and thing on the stack, which is like this argument which is at depth 3, this argument which is at depth 5 need to be copied. This one which is at depth 7 needs to be moved to the top of the stack. Okay, I've called my function. This was argument by reference. Therefore, this on top of the stack is now this value that has this name. And like this is going to be part of the, again, register allocation part of the lowering in 2-byte code. We're not there yet. I have ideas for how to do this, but we're not there yet. Oh yes, I meant to replace the generic params by, since generic params are just a list of names, I can just do, yeah, a long, like I've had the idea for this project of like making something that generates speed code for 2 years now. A lot of the why I was procrastinating actually starting the project was I wanted to write the reference of the language before actually starting the stream, so like I could point viewers to like this is what the language definition is. And part of this was I wanted to know how I would implement things and have a plan before moving in, before starting with the project. And that meant figuring out how am I going to make everything work with just a stack. And that's part of why it took me a long time to get started with this project, is just because, yeah, I had to figure out how I'm going to make things work with just that. Is that the best solution? I don't know. Am I confident it works? Yes, I've handwritten Piètre programs that do things like this, and it works. So, but yeah, I think the most difficult parts of the project, the ones I'm dreading the most, are gonna be lowering into the AR, because it's gonna be basically control flow analysis, and especially since I want to do a strict single assignment IR that is basically based on the LLVM one. And that's gonna be a bit tricky. I found a research paper that like clearly explains the algorithm to do that in one phase, like both doing the control flow analysis and generating the strict single assignment form. So I'm gonna follow that. But that's, even then, that's still gonna be a lot of work, especially since I want to make a small change to the way they do it in the paper. And that, and the lowering from the AR into the bytecode generation from the AR, which means again doing the register allocation thing, that's going to be a bit tricky as well. I don't think it's going to be like the end of the world, but I'm dreading the streams where I have to do that. Basically, those are going to be fun, because here it's a lot of like, busy work is not the right word, but I've already done the actual busy work, which was writing the grammar last time. Um, yes, the only thing is, Pete, I've made, actually, if you go to the GitHub page of the project, there's a link to the YouTube. I've made 2 videos for this, like the small social media announcement thing, but a 10 minutes video ish that talks about why the project exists, that goes a bit into details about like how Pete works, basically. But the gist of it is like, your image is decomposed into blocks of pixels of colors, well, size independent pixels, and it's the color transitions from one block of pixels of a color to another color that encodes the instruction. And there's 17 instructions. They're fairly limited. You have like your basic arithmetic operations. There's no support for floating point arithmetic at all, and you have a few stack manipulation functions, but very few. And some of the instructions are about redirecting the evaluation of the interpreter, like redirecting the interpreter, as in, hey, next you should go right, next you should go down, that kind of stuff. And so there's a very visual aspect to a Pete program where like there's a path through the image you have to follow that is encoded with instructions. The way I'm planning to do it is basically each function is going to be a column in the image that goes like up down, basically like up down, with a circuit between functions that is my go-to system, basically. And every time you do a jump or a function call or something, it exits the function, joins back to the top of the image where it has this like address selection thing that based on the number at the top of the stack redirects the execution to the right part of the image. Well, yeah, I'm the main limiting factor is there is only a stack, there is no heap, and I have like push, pop, roll, and that's about it. Everything has to fit with like those three things. So that's why like already having generic arguments in the language is a tiny bit ambitious because again we're dealing with a very restricted language. Something I've had in mind is also like maybe some other stack based languages, like maybe some making something that exports to fourth based on the IR might be possible. And that could be interesting to do. Something I also want to do is since I'm planning to base the IR on the LLVM1, I'm planning to do something that basically exports from our IR to the LLVM1 to be able to actually compile our programs and run them. Since we are a much simpler subset of Rust, exporting from our IR to something that compiles to a binary using LLVM should not be too complicated. Famous last words. And that would be an interesting way to compare execution and have another form of testing of like, okay, we compile to space filling curve. That would be interesting. Yes. I am not planning to, since like it takes several instructions to actually do any rotation in the image. That would be, I think, manually crafted. It would look incredible, but generating this, I'm too lazy for that, I think. But I mean, the project is open source. If you want, when we have the whole thing working and there's a bytecode to image thing, you want to make your own version that makes space filling curves for the image generation, please be my guest. Yeah, I think the generic parameters, since they are just a list of identifiers, as in the name of the parameters that need to be featured in the thing. I think I'm just gonna make it a list of identifier for now. This is gonna be $2. And I'm gonna rewrite all of those generic. Oops, what am I doing? To be instead, this is gonna be a list of identifier. Something that could be fun as well, beyond like with this idea of like space filling curves, would be to have something where, as long as there's a way to make it compatible with the notion of like address and everything and having a circuit, basically, having something that makes the functions fit into something a bit nicer and like adjust them to some shape or something. I could make something that like tries to generate shapes and fills the space that's unused with random pixels. Like we could do something in which like a bunch of programs are exported as the frames of Bad Apple or something, as long as we allow color instead of just black and white. But that might would that work? It might work. It might be doable. But that's a stretch goal. That's not part of the goals of the project. Okay, so that's it for the generic parameters. That's it for everything so far. Let's move on to a block. A block is maybe not something I want to keep that way. Maybe block I can inline, and block is a list of statements. Exactly the way it was already written here. And I'm tempted to do the same thing here. I have this grammar differentiation between block statement and inline statement. That being said, for the grammar, it's useful to have something like those have a semicolon and the others don't. It doesn't hurt to keep it that way. I'm just gonna inline it here, however. So we have an if statement. We have a for statement, a while statement, a let statement, a return statement, a continue statement, a break statement, and an expression statement. This is something that might be actually because for now I'm using the same type I've used as part of the lexing phase, so it's just an alias. So it's not declared as part of this basically. I don't know if I want identifiers to have an AST phase. I think it's more like the thing that knows about identifiers has one. But I might change my mind on this. But I think identifier is basically just a string underneath. It's just a new type over a string. Well, a text, but same difference. I don't I think it would be too low level for that to make for it for it would not make it would be too low level. It wouldn't make sense for it to be differentiated based on the phase. I think this is one of many things I might change as I progress. As much as the shape of the AST, I have a rough idea. This idea of like how do we do the different phases and the compilation, that's something I have not given a lot of thought yet. I will do ahead of the stream when we actually do that. I know the rough shape, but I have not actually given like a lot of thought about like, what the different types of faces will need. That's something I think we should discover as we go. Like, oh, here we would really need to have this. We have an extension mechanism that's here for us to store information, basically. Like, I know this will be useful. I just don't know yet how. Actually, continue statement and break statement, no, they do need something. They are going to contain an x continue of p, which is going to be the additional information associated with this, which is going to be for all of those the location at first. X continue, X return. I guess I could just copy and paste. Might be easier. Ah, it put it in uppercase. Oh well. So much for. That was going to be. Okay. So return, continue, break don't need anything. They don't need an argument because they're just that. I've called it Piètre. That's what it is here, which is a French word that means mediocre, second rate, shoddy, kind of, which is mostly because like meant to suggest that like that's not a project that should be taken too seriously. It was also intended as a pun, but it doesn't work. And that's because I've been mispronouncing the name of the language Pete for 2 decades. Because the French pronunciation is slightly different, or maybe my pronunciation is different. I'm not sure, but as a result, the pun just doesn't work. So it's a second-rate pun, I suppose. Wait, actually, return might take something. Return has something because return may have an expression. So return has a maybe expression here. Continue statement don't. An expression statement has an expression. That's what it's all about. Do I want for the if, for, while, and let to have their own structures? Maybe that makes more sense. Yeah, especially since the let might have a type. So this would be an yeah, especially for an if, since it might have a chain of else's, basically. I'm not sure how I want to represent this actually. Is it gonna be a tree? By default, it's gonna be a tree, basically, because it's an else statement which contains itself. So I guess that's what makes the most sense before transformation. So probably that, yeah. Just align this vertically because it's pleasing. There we go. I need to add those extension types that I might change. I think for most of them are just gonna be location for now. Oops. Like maybe this is overkill and we can simplify later, but for now I would rather err on the side of caution, since I am not completely sure yet what kind of information I will need in the different stages of the AST. For now, I am being very verbose. Each constructor like this takes its own type argument like this to represent. Actually, this is wrong syntax. Each of them has its own associated type, extension type, so I can decide what I want. And maybe when everything else is said and done, I'll realize actually half of this is not needed and I'll reduce. But yeah, Rust actually defines them as expressions, as in they have a return type. I've simplified things a tiny bit, and I haven't made them expressions. They don't have a return type. Uh, Unlike in Rust, the return statement is therefore mandatory to return values from a function. And the only reason I've done that is just it's simpler from an implementation perspective. At least I think it is. To me, it feels simpler, which is why I've done it that way. From a grammar perspective, I think it doesn't make a big difference. But that's why I have this like statement and expression differentiation. Okay, next. What do we do? So if, for, while, and let. I can already do some of the stuff here. So if I'm not gonna do yet. Actually, all of those, I'm gonna keep this distinction just because it allows me to. This is just forwarding the statement unmodified. Nothing changes here. And likewise here. Okay, so here the if, while, for, I'm gonna have to figure out. But this is probably gonna be, this is statement as well. Oh, statement passed, actually. Else, I don't know yet because it's going to depend on how it's done, which is going to be the same type as this, basically. Which I guess is going to be like either else, either new if or block, basically, like a tree. I don't know yet. While is going to be a statement as well. For is the statement as well. Let is a statement as well. I might want to do something different here. I mean, that's not a bad idea, and that I think it's how how it's done in Rust. I think, but it means having to decide on semantics for what the expression of a given statement is. It means rewriting the language to be like that, and I think from an implementation perspective, saying no, statements don't have values, only like returns and stuff have explicit values, I think makes it a tiny bit easier. Partly because it means I have very little in terms of type inference. I have there are very few places in the language in which I have to guess the type of a thing based on the expression that's given to me, and reducing the amount of type inference I think is going to make things a lot easier from an implementation perspective. That's part of the reasoning, is reducing the amount of like hidden type information, basically. I've considered, I think at the moment in the grammar, the let statement does not mandate the type, uh, but because I think I think there should never be any type ambiguity at the moment, given the way the language is defined. There are very few type level shenanigans and things like this. There isn't even support for floats because floats are not supported by Pete. So there should never be any ambiguity about the type of something. So in theory, there should not be the need for type annotations that much. We'll see when we actually get into the weeds. Wait, yes, I think I want to introduce a new rule. I don't think I want to have an expression here directly because that's the actual expression that's being passed, and I think I want this to be an expression statement that converts into an expression properly. And here, that's annoying because I will need the location there, and I don't have it. Unless expression itself gives me the location. No, not really. No, I'm not gonna go that far. It's the upside of working on a simplified language is I'm not going to go all the way and do that. I think I'll have a look at to see what it would entail, but it's not the plan at the moment. The plan is to do something a bit more ad hoc and a bit simpler. But maybe that would be the right approach. Hmm. I'll think about it. I'll think about it. But no, the plan is to do something a lot simpler. But plans might change. I think, yeah, I think the thing is, I think expression is gonna have to give me the location. And if expression gives me the location, then the expression statement is just an expression. And here I can uncurry expression statement to make it a function that takes a tuple as an argument. There we go. This is another one. There we go. This is just a break statement. There is no argument. I'm not doing multiple loop break and stuff. So it's just a break statement with the location. Just a continue statement with the location. And a return statement at this location with this expression, if any. Okay. So this is going to be wrong. I'm going to assume therefore that everything that an expression returns contains a tuple of the location. Okay. That's fine. I don't think I had any expression so far. No, that's not true. I had one expression so far, and it was in a constant declaration. There we go. So here I need to drop, if I don't care about the location, and I don't think I do at this level, because I already have the location of the constant declaration, I can drop it by just doing a second of $6 here. Okay, next. So that's everything here. We're missing if, for, and while. For is not that complicated. While is even simpler. Let's do them and let's keep if for last. So a for will have the iterator name, the variable name, an identifier. A for will have a range expression, something that evaluates to a vector in some way, shape, or form. Could be a constant. Could be that's something that could be absolutely optimized to be evaluated at compile time, and maybe even transformed into a series of statements if that makes like I could do loop unrolling actually, yeah, as an AC transformation. Which is an expression, and we have for range block or body. Let's go with body, which is a list of statements. Then we have a while, which is almost the same thing, except there is no variable name. While range expression, and a while range, well, a while. There we go. Okay, is that correct? I think that is enough. So now we can do... Oh, I haven't done the let yet. I need to do that. So for this is going to be a for statement of the location indicated by the keyword that contains the identifier, which is the variable name, $2, the expression, which is $4, and I need to drop here the location, so that's the second value of the $4, and the block, which is $5. Actually, no, this is a for with those arguments. There we go. Now, same thing for the while. If I could type, things would go a bit faster. This is a while statement in which we create a while. There is no identifier. So we just get the expression and the statements. Okay. Now, what's a let statement? Yeah, since there's an optional type, I'm gonna make it a separate type. So this is gonna be a let. We have an identifier. We have an optional type. So this is where we're gonna have to do some type inference, but I think of the entire language, this is the only place where we do type inference. Because every other thing, literals are strongly typed. There is no float. There isn't any different types of integers we have to convert in between. Until we have generic arguments, and even then, it's like I call a function that has a generic argument t. Well, this variable I have is an int, t is int, and then I can type check the rest of the function with it. I don't think there is going to be at any point the need to infer. Because literals are explicitly typed, functions are all explicitly typed. And I don't think there's any expression that has an ambiguous type, basically. So that should make type checking a lot easier. I'm trying to think of like the limits of the language, but no, I don't think there's any place where we need to make a guess. I mean, here we're gonna have to. At parsing time, we won't know it. That's something where we're gonna have to resolve it because, well, yeah, the expression can be anything and its type. This is something where like we're gonna do type analysis and we're probably gonna be replacing some of the information in the EST by like, no, here's the type at this stage of the. Yeah, I don't see why not. Like they need to be consistent like all generic arguments, but since there's no difficulty, there's never gonna be a difficulty in deciding the type of an expression, I think. Partly because return, break, and the others are not themselves expressions, so every expression is like very self-contained to like something that has a known type. That means when doing type analysis for like function arguments, I can get the actual type of an expression and then I can try to match that with the generic argument of a function, and then I can just check for consistency. Name type maybe type expression. What am I missing? I'm missing the expression, which is also an expression. There we go. Why are you red? Because I typed things wrong. Okay, now here this is again the same thing. We create a late statement that has a position, which is the position of the token that introduced the thing, and we give it as an argument the let, which takes as the first argument the raw identifier from $2, which is the identifier here, $3, which is the optional type expression. So this needs to be a type expression passed, and $5, which is the expression, and likewise we're gonna discard the location, and therefore just second of the tuple. Okay. This is forwarding the type unmodified, and we've done everything except the if, I think. Okay. So what's an if? This is gonna be... Oh, there's gonna be the expression. Let me think. Okay, so this is gonna be an expression. There's gonna be the body of the if, which is the same thing as all the other bodies. It is a list of statements. And then there's the else. What is an else? It's maybe either an other if or a block. Yes, the purpose is documentation basically. As in, you can write the type, and the compiler will like same thing as typing some expressions in Haskell, where like yeah, the compiler will figure it out. But if you give it type information, then you'll get it, and if you get something wrong, you'll get the error at the assignment place and not at the use place. Because if you do let x equal something and then you use the x thinking it's an int, you'll get an error using the x. If you say let x like colon int equal something, and that something does not evaluate to an int, you'll get the error at the assignment. So documentation and early errors, basically. But otherwise, yes, it's not for the purpose of disambiguation. It is for the purpose of documentation and early error. In the same way that, like, when I do a function in a where block in Haskell here, if sometimes when I do something tricky, like not like this, I will type those functions, because if I make a mistake, then rather than the type of this function being wrong and therefore the type error being where they're used, I would get the type error where I declare it, and I can like look more local errors basically. So same logic here. So that's the if body. Yeah, I think for the else, I'm gonna do this is a maybe of either an if, maybe rather than okay, I'm gonna do the same thing as earlier. I'm not like I didn't use a boolean. I'm gonna not use an either here. I'm gonna actually do this properly. So this is gonna be a maybe else, and an else is either a else if that contains an if, or it's an else block that contains a list of statements. Okay. I realize I haven't written a single deriving show on any of this. I'll have to do that for debugging purposes. Okay. So now I can do this. An if is a statement passed. An else statement is an else passed. And an else block is just a list. Oh, wait, no, that's the else passed. So here, I'm just going to copy the for thing, or the while one, actually, maybe easier. So this is an if statement at location $1 that contains an argument, which is an if, which contains the expression, which is indeed second of $2, and a bunch of statements, which is indeed $3, perfect, and then contains a maybe else, which is the $4. Okay, perfect. Oh, except, yeah, wrong parenthesis here. There we go. And the else statement is an else parsed, which is else followed by an else block, and I'm just gonna forward $2 unmodified. And this else parsed, in the case of an if statement, will be an else if Ah, this statement passed here means I cannot get the so I probably want to decompose the if statement from the if expression. Huh. So instead, well, I could just do it that way, which is a bit inelegant because it is inconsistent with everything else. This is a location and an if passed. So basically, this returns this. And so here I can return the second element of what we passed, which is going to be the if itself. Perfect. And here it's an else body or else block, whatever I called it, else block with $1 unmodified. And that means, however, that here for the if statement, I need to uncurry if statement $1. Maybe I should do that for all of them. Maybe I should do that for all of them. For consistency, basically. As in, apply the constructor if statement while for statement while statement in here, while the expression itself, well, this part of the grammar returns the underlying value. But that's not how I've done things for any of them. So I think I'm just gonna keep if as an exception just because I need it. If I end up needing it for more things, which I think is unlikely, I might change it, but for now I think this is fine. Okay, so that's if else. So that means we should be done with everything all the way until expression, and it is getting late. Do I want to keep expression for next time? I think so. I think I'm gonna try to see what if this compiles. So it's gonna be missing a few things. It's gonna be missing expression here that I have not declared. I don't think there's anything else. I think everything else is expressed in terms of expression. Okay. Yes, this is called while. So now let's just try to compile a few things and see. Okay, so we very quickly get into, that was the only error in the AST file, so that's pretty good. We immediately go into errors into the parser. Because I think the parser doesn't have access to the AST. Because here we have definitely defined module, but the parser complains that module is something it doesn't know. That's the generated happy file. It's monstrous, which is why we're not gonna be looking at this. Let's go back here. Yes, representation AST is missing. Okay, so we're back to compiling the AST. Here I am missing import. Is it data kind? I think it is. It was. We're missing location. I'm gonna need tokens just because that's where the identifier is declared for now. Ah, yeah, of course, in them is already a thing that exists. I guess I could change my naming scheme to instead being info. Let's do that. So an enum declaration takes an enum extension and an enum info. Yeah, that's not the worst naming scheme. Oh, as long as it's consistent is the most important part. Function archetype can stay. Statement can stay. I think declaration can stay as well. Like the ones that are branching like this can stay, and then this is an if info else info. Ah, that's inconsistent. It's not the end of the world, but it is inconsistent. Let info expression is fine and can stay that way. Okay. So now we're going to need to change it everywhere inside here as well. Those will need to change. Okay, I think everything else is fine. And now let's go back to the parser and let's change that. Identifier that hasn't changed. I don't think I need to put it a lot because most of the time we just bundle the thing directly into a statement or a declaration. I think the only place is here. This is an if info, and an else info. There we go. Let's see. What's next? Type X isn't defined. For now, I'm just declaring them as empty data types, which is not something that makes... because there's a typo here. There we go. So for now, they're empty, which means... descriptor is not bad, yeah. If I'm trying to avoid doing the thing that a lot of Haskell programs do, which is default to like abbreviations and single letters, because a lot of people arrive at Haskell from math and it's like, yeah, everything is F, G, and I, it's fine. And I'm trying to avoid that and name things in very, very explicit names. Can't make a deriving instance of semigroup module because it cannot... okay. So I can't do that. Can I do a deriving instance semigroup, or is it going to complain about that as well? Yeah, I can't make a deriving it. Okay. So I'm going to have to make my module a semigroup explicitly. Yeah, absolutely. This is actually valid Haskell names that you can make the apostrophe part of the name. So F prime, F second. Yeah, absolutely. Valid names. I mean, Haskell even has the thing that I call the curse of Haskell, which is great. It is fantastic and can be used in such a wrong way. You can just create your own operators. You're making a DSL, you can create your pipe plus plus pipe operator. It's fine. You can. And you can even specify if it's right associative, left associative. You can specify its precedence. you can make a DSL. It's great. And no one has ever used it wrong. No one has ever like made Haskell code unreadable with too many operators. Has never happened. Absolutely not a curse. Use it freely. No consequences. So here I'm just gonna define it manually since the compiler can't derive this from me. So if I have a module with some useDecl, actually, since I call them import, I'm gonna call them imports here as well. Well, I mean, here I'm not going for my fake language. I'm not going all the way to emoji as identifiers, but I am accepting any Unicode character that the Unicode consortium considers a letter as a valid identifier, which is part of the reason why we had so many issues with Alex, since Alex only deals with bytes and ASCII input, basically, and hence the need to revert to manual processing for identifiers. But yeah, I allow if anything is considered a letter by Unicode, valid identifier. Kind of on purpose, because I thought it would be a challenge. I was. So if we have a module with imports 1 and decls 1, and we try to concatenate that with another module that has imports 2 and decls 2, the result is a module that has the concatenation of the imports, preserving the order, and the declarations, preserving the order. And I can now make this a monoid by saying that my module P has an empty, the notion of an empty module, which is just a module with empty lists. Okay. Wildcard underscore. Is that the 2 only errors left? Nice. 2 only errors left. Let's go back to the parser, which means at the moment we're still gonna fail if we try to parse any expression because like we have undefined absolutely everywhere. So it would just like try to evaluate undefined and panic. But we're getting closer. So this is gonna be. And this is a generic argument, which is a comma list of type expression. So this is a list of type expression parsed, which means it is just $2 here. And with that, that should compile. More or less. What's wrong? Missing. Yes, of course. I have a bunch of places where I say expression, but that's no longer true. So I am going to have to do wherever there is expression closing brace, I need to change that to like expression parsed. And like here, and here, and here, and here, and here, and actually I think all of them. There we go. And I think actually most of them will be tuple location expression parsed. I have one that I have missed. Ha. Ah, here. Okay. mconcat is not the correct. Okay, so now we're getting errors within the braces that we have used to create our expressions. So here, the mconcat I'm using for modules is wrong. Yes, because of course, this is not just the function to apply, I need to list the argument explicitly. So that's why. Now, cannot match location token with text. So that means I have somewhere an identifier, here for instance, where I forgot to call the get raw identifier. There we go. Couldn't match type location token with text, so that's again the same problem. Where else do I have? Well, here. Ah, yes, I have here. I have created the info types, but I do name them in the constructors here, so I need to change that. So that's a type alias info. Enum info. Struct info. Const info. Function info. What else? Probably for the statements as well. Yes, if info here. While info. For info. And let info, which is here. That should be most of them. What are we left with? Couldn't match text with identifier. Ooh. Oh god, debugging happy errors with their absolutely monstrous types. I'm not sure. Oh, that's a fairly early rule, so that's probably something fairly early. Expression where I have a location token. That's interesting. Because location token only happens for literals. Yeah, a bit, isn't it? The documentation has a few things about making happy happy. It's a name that lends itself to puns. So having an expression pass and having a token, that's probably the literals, because that's the only place where the token returns the full token and not just the location. And I think we've handled all of the identifiers. So that means the one that we have not handled properly are probably the literals. But I have undefined here. So that means no, here undefined will be the correct type regardless of what, so that's not the problem. Okay. So now the problem is trying to figure out the type errors based on the state information that I have, which is not always easy. So here there's a problem of text and identifier. I'm not sure where that is. Let's process by elimination, I guess. I guess I could look into the generated grammar file to look at the which rule that is, so I could figure out which of my rules it actually is. If I'm stuck, I'll do that, because I think that all of it is going to be fairly straightforward. There are things that have text. That's interesting. Ah, maybe 0 with list identifier. So that's an optional thing that I do not fold properly. This optional is fine. That's correct so far. That's a comma list. Oh, that's one of them. Here, that's a comma list of identifier rather than as a so that's gonna give me a list of location tokens. So here I probably need to do a map second to extract things. That's one error already. This error is monstrous because it doesn't give me in the third argument of happy reduced, namely happy reduction 21. Could I look at reduction 21 to see what the type is supposed to be? It's not just an error. Okay. Hmm. Rule 21 is function declaration. So something is wrong probably in my function declaration. So here this is a declaration for past something, and I'm saying that the result of this is a function declaration where the location is $1, which is the location of this token. And then I get a function info with get raw identifier of $2, which is this one. The optional generic parameter is this one, 3. 5 is the optional comma list. I need to fold this. I did not. Then I have the optional return an 8, so that was an error already. Okay. One of those still in happy reduction 21. Happy in 41. What is 41? It's an if statement. So I have something. Oh, it's an if statement after an else block. Actually, there's probably the list of rules at the top. Yes. 41 is else, an if statement after after a else. So here I'm saying that in the case of an else statement, I return an else info past. So here that's 1, 2, 3, $4 the last argument to the if info. Yes, is supposed to be this if else, but it's a maybe that's correct because it's an optional of an else statement. Else statement is an else info pass. That's also correct. And it's the value of the else block, which is the second thing. And here I return else if, and else if it's an if statement. I return the second of $1, so I return the if info past. That's indeed what an else if is. Where here I return an else block with the list of statement, which is what block is. Yes. So that looks good. So I don't know what's wrong here. Let's see if there's any other error that has like a pretty obvious problem. Reduction 117. The location expressed in past there again. So, okay, those I can probably figure out. It's not at the end of the file when we are passing expressions because we are returning undefined for all of them. So it must be where I call expression earlier and I do not here 1, 2, 3, 4, 5, 6. Yes, that's correct. I do not decompose. No, I decompose it. That's fine. I do here as well. For identifier in expression. That's the fourth. No, I do call second here. Equal expression. I 1, 2, 3, 4, 5. I do decompose it. Aha. Here in return, I do optional expression and I get a maybe that is incorrect. I need to do an fmap second in this one. Okay, this one is correct. Correct, I think. I'm uncurrying expression statement to make it take a tuple of location expression. Okay, so that should be fine. Okay, so still a few errors. Text and list of identifier. Let's go to the bottom of the list. Let's see if there's anything else that's useful. Here I have a very verbose type error in rule 151, was it? Reduction 151. Optional generic params. Oh, that's going to be a raw identifier issue there again. Yep, because that's a list of identifier. And here, oh no, ha. Huh. However, this is giving me a list of identifier, and I might be forgetting to fold them somewhere. Generic params. Yes, here I should fold them, and I'm not. That's part of the function declaration, so that might be one of the errors we had found. Here, struct fold, here they are folded, that's fine. Optional, they are folded. Okay, so that was one that was missing. I was not folding the maybe list correctly. What else do we have? Is that the last one? This looks like the last one. So this is the 117, which I think was the else. And it's an expression problem. Okay. So 117 was... Oh, that's different. Oh, 117 is a comma list array element? No, sorry. Comma list identifier. Interesting. Token with text. Yeah, I can see how that would happen for a comma list identifier. Okay, so let's look at all of our comma list identifier. There's one here. There's only one, actually. Wait. Yeah, that's the one. So that's the only case where we have a comma list identifier. So here something is wrong. Hello. We're mostly done for the evening because I'm not going to push a lot further because it's getting late for me. Today we debugged a few things in Alexa and we've made a lot of progress on the parser by defining the AST, a very rough first draft of half the AST and debugging some of the parser. I'm trying to make it compile and there's a few errors are left where some of the expressions in the braces where I associate Haskell code with a specific series of tokens in the parser is wrong, and the error messages are a nightmare to debug. And this is one of the last ones. So here, when we do a comma list of identifier, we do get something wrong. Oh, that's because this is not valid syntax. That is not valid syntax. There we go. That should be better. 1, 2, 3, 4. This is a comma list of identifier that gives me a tuple of location and the identifier, which means when I get that list, I should do a map second on the list to get a list of identifiers. And I think that's what import needs. Oh no, it's not. Oh, yeah, no, it is. Specific takes a list of identifiers. So that should be fine. Okay, so with this syntax problem fixed, Which actually, since Happy uses dollar as a meaningful character, that was probably some of the issues. We should see 117. No, we still see 117. Huh. What is wrong then? Because comma list, otherwise the type has been correct. It would not be. We would have had other issues if the type of comma list, if comma list was incorrect. So I don't think comma list is incorrect. This is the fourth argument. So that's fine. Maybe this error is the consequence of another error, so maybe I should go fix the other error first. However, I'm not sure what the in 41 means. What is rule 41? That's the else. That's the else. That's an if statement after an if block. Huh. But I don't have expressions there. The fact that I get a location token means I have some identifier that's wrong, I think. Because the only thing that gives me a pair location token is identifier and the literals. And we don't deal with the literals yet. So it must be in all. That's a good question. I'm not sure what the memory allocation thing of text is. It's not as bad as string, which is a single linked list of text. This might do a lot of allocation. I know GHC uses a special type for this, which is probably something that does that optimizes the memory allocation. I have not looked into that yet. That's a good question. I'll look into the type that GHC uses for next time. I wonder if actually text supports some amount of like viewing, but I'm not sure. Possibly. Wait, I was looking at, yes, my if and else. I think somewhere in there I have something where I get an identifier and I use it wrong. Wait, why am I? Oh, no, it's an fmap because it's an optional, so it's a maybe. So I need to indeed fmap inside the maybe. That's correct. What's the type of my if thing? Because I think that's where something is wrong. The expression is here. We do discount the location correctly. $3 is the block. That's correct. That's a bunch of statements. And then $4 is an optional else statement. And it's a maybe else info. Okay. We've written the second value here. Else if we disregard the location. Is that correct? Yeah. Huh. I don't know what's wrong here. There's nothing obviously wrong. I know it's a problem with an identifier. That I know for sure. So I have to check. Wait. The for declaration is variable name identifier first, range expression second, and body third. Identifier second, expression body 1, 2, 3, 4, 5. That's correct. Could it be in the while? No, that's correct. And the if I have checked several times. What is this? What is this? It would be very useful because it's clearly an identifier problem. Okay, I'll bite. Give me the generated file. Okay, so this is in happy reduce 62, in happy reduction 62. Okay, so maybe I was looking at the wrong thing. 62 is path expression item. Haha, with identifiers. Oh, is it? Huh. OBS is telling me that like I'm hitting the yellow consistently in OBS. But maybe when I'm like this, I'm not talking in the microphone. Yeah, maybe I should like make sure to lift my head when I'm talking in the microphone. Okay, so the error is in the rule 62 reduce. So something is wrong with our path expression item. I wonder actually. Aha! Aha! There we go. I thought all of my expressions were left undefined. One of them was not. This one here was not. And that one that I did not do this evening is the one that was written in the wrong value. There we go. Oops, how did I do that? There we go. And hopefully that's the last error. It is not. But there's only one left. And I wonder it's the same thing where like in the part of the codes I haven't touched this evening, I have something. No, comma list type X, that's correct. Type X, that's correct here because I have undefined. No, it's not something where I've put something else than undefined, I think. Okay, so likewise, let's go in the generated file. So token with text. So it's again an identifier problem, probably. And this is happy reduce 117. So again, rule 117. That's our comma list of identifier. Again, what's wrong with it? So here, 1, 2, 3, 4. That's a fourth thing. A comma list of identifier will give us a list of tuple location token. And we want a map, a list of just the identifiers, because this is the specific import thing here. So we just want the identifiers. So we're doing a map second on this $4. I guess I could check that the error is here by adding an undefined here that will transform the comma list as it needs, and if this compiles, then the error is here. Hello. Sorry, I missed your message. It is lagging like hell, which is a good sign. It means it's probably compiling. Okay. Okay, that works. So here, this is wrong, and I don't understand why. But that's the last error of the evening. I'm just gonna fix the other thing here. This is not this either passer or module passed. There we go. Now that we have defined an AST. And that should probably be called parse module. Or do I want this to be named parse module? And how do I call this then? Module parser? Yeah. Which means I need to change here. This is now module parser. And it takes module, which is the top level thing, as an argument. Okay, so what is wrong in this comma list of identifier? I am very confused. That I had to use an undefined for. Wait, huh? Didn't I use... Oh, no, because I removed it, okay. Okay, so here, this comma list of identifier is wrong. So identifier is a tuple location token. Oh, of course. This is not second that I want. It's the get raw identifier function, because I would otherwise get the token, not the identifier. And now this should compile. Yeah, okay. It's lagging, which is a good sign. It means it's compiling. Which means we've defined a few things already. Perfect. Unused import. That's the kind of error we like. Because those happen only at the very end when everything else has been processed. Perfect. This compiles. It still doesn't work because our AST for expressions is still an empty type, and passing an expression is, for now, still a bunch of undefined. But we have fixed a lot of errors in the grammar. We have a lot fewer shift reduce errors, like in ambiguities than we had last time. Conflicts, that's what I'm looking for. And we have passing of everything except expressions, basically. And I guess we could try. Put the problem where you can see it. Stack GHCI. Oh, I did not derive a show instance for anything. Yeah, usually error-driven development is a lot easier for when I get actual Haskell errors and not, hey, something is wrong in your grammar file at rule 117 or something. That's why I'm very tempted, as I was saying earlier, when I'm done with the AST, before moving on to like some of the IR and stuff, taking a break and doing the image generation stuff, because it's gonna be like a lot of like no intermediary language and a lot of like pure Haskell code, and a lot easier, I think. So it's gonna be taking a break and just doing the bytecode. We want to try parsing a module. So that takes a file path, which is also a string, and the text of the thing. And it returns the module. So I'm going to just quickly change one thing. Let's put a bunch of show instances on all of this stuff. which might not work because of the whole trees that grow phase type. Yep. Yep. Okay, so what that means is I'm gonna the reason so the thing is most of the time when this is expressed as a type family. And the reason I didn't do it as a type, as let's say, of independent type families, and instead I've grouped them into a class, is that I can express all of the constraints grouped at a class level. And that means then, since the class needs to exist anyway, I can just use the class constraint as a way to have also all of my instance constraints. That being said, would it give me the same errors if I just had a type family? Or would it figure out that... No, I think that the error would be the same. I think this is correct. Okay, so I want all of them to have show. So X type alias and so on, which means I'm going to do that. This. This. Okay, so now I'm saying for this to be a valid AST representation class that lists the type that are the annotation for the things in our AST, also, like for this to be valid, all of these need to have an instance of show, which means now I should be able to replace all instances of deriving show with a new line. Deriving, and that would be AST representation. P implies show. Oh, I can't do that. Okay. I can, but I'm gonna have to fix the thing afterwards. Okay, let's do that again. Show I can replace with a new line and instance AST representation of P implies this can be show, and this is gonna be not always module, but it's gonna be a type like this. And probably a deriving instance actually. Let's try for module. Okay, so now I have to fix all of the type names. Import. I should have done this as I was doing it, because that's gonna be painful. But at least next time I have to add another instance, I can do it by duplicating the existing instances with regular expressions. Gonna be a lot easier. Info. Struct info. I should also add some spacing. This is unreadable. And some comments, but that's not going to be this evening. That's function info. My battery is low. Let's charge this. The stream will not crash if my battery dies, because it is not the computer that's doing the stream is not the one I'm typing on. I'm using a capture card. So in the worst case, if my laptop dies, we just end the stream on an unsatisfying conclusion, but that's not the end of the world. Sorry, this part is just a tiny bit manual and repetitive. As soon as I'm done with this, we can try testing our parser for some very simple things, anything that doesn't have expressions. So, few things. Next, this is a let info. Okay. Oh, yes. You are actually fine with just a deriving show because you don't have a type parameter. Okay, and now I need to replace all of those instance show this, like this. This is a deriving instance. Okay, that should be it. So now we should have a show instance for all of our types. We have to recompile the parser. That's gonna take a while. I had seen something in the Happy documentation about the fact that like compiling Happy was slow. Well, compiling something generated by Happy was slow, and indeed it is extremely slow. Okay, let's reload that. Okay, so now we should be able to do a parse module. Give it an empty string because we don't care, and let's try to parse. Let's try to parse a module. So we should be able to do use foo bar the bars like this, and then after a new line, is there a semicolon at the end of a use expression? Yes, there is. A new line, a use, a use. I don't know. This star. Let's try that already. Parser error. T delimiter braces open. So that's not the correct syntax for this. Ha. That doesn't work. Great. Is it a spacing problem? No, it's not. That is a tiny bit unpleasant and disappointing. What does that mean? What is wrong here? It doesn't. Okay, so here the only thing I have when I call happy error is location and token. So it does not. It doesn't tell me anything else. I think there's a way to get better errors here. Oh, I wonder if it's a matter of like. No. Okay. Okay, so if we lex this, then. Let's print this line by line so we can see what's happening. Use for operator. What? Oh, yes, this operator, yes. That's correct. Bar, braces open, baz, braces close, semicolon, use this operator type, operator star. Okay, so that is it lexes correctly at the very least. So that means that when we encounter one of those tokens, the parser gets confused. The fact... Okay, let me see. Let me look at Happy's documentation. Let's see if... So I think there's a way to get better errors than just the token at which it fail. No, that's not there. That's not there. Would it be... Invoking Happy? Probably. Ah, wait, it's not called Happy Error. It's called... I'm the one who gave it that. It's called... It's the error thing. Okay. So that's probably in using Happy. There we go. Huh. This gives two different values to error, and I only give one, so there's probably something... Two action form of the error directive. Ah, the second function is called for the user to print or collect the error message. Okay, so what's the type of this? What is it expecting? Here, if I make a happy error that takes nothing and returns a parser of A, it's going to complain that the type is wrong. So it'll tell me what it wants. What do you mean parse error? Ah, it's probably because this is not... Huh. Does my version of happy not have the double %error thing? See the documentation for error, which is a link that's broken. Error directive. deprecated in favor of the... Okay. Aha, there is... There we go. That's the word I was looking for. Okay. Reporting expected tokens. There we go. So if I say error.expected, it will give me the list of token it would have wanted instead. Okay, let's try that. And now this gives me... So if I go back to my happy error function, so now that's not just a token, it might be actually, but it's also a list of string. And I guess I can... If it shows me the empty list, I'm gonna be mad, but... Unwords the expected. Okay, let's try that. So my error function, lexical error before the dot. I haven't changed anything. Unless my version of happy doesn't support this at all. Huh. Yeah, I might have either too recent or too new a version of happy, because this doesn't work. And I am on latest. Huh. Well, maybe I'm on too old a version, and this is the syntax that's expected. And I need to do... Oops, and I need to do this. Let's try, and if it doesn't work... I don't know. If it doesn't work, I'm left to debug... Ah, there we go. And words. So my version of happy is slightly too old. Okay. Except it doesn't seem to be working because happy error still takes the... Okay, so the... Ah, okay, I see. It gives it to me as a tuple. So that's why it's doing expected. There we go. Oh, I'm an idiot. This is a list of string. And in this tuple, this is expected. There we go. I'm getting tired. It's time to stop. When I'm making silly errors like naming my variables at the type level, it is a sign that maybe I should take a break. Yeah, I've been at this for 4 hours. But I'd like to understand what's not working here. Parser operator star expecting identifier. Ah, that's a shift. That's a shift reduce conflict. That's a shift reduce conflict. This is because we have this use path, which is identifiers separating by those double colon operator. And here, after a use path, it encounters this thing and thinks, since it's doing a shift instead of a reduce, it thinks it's still matching path items and is therefore failing. Okay, so that's something we can fix next time. That's a shift reduce conflict, I'm fairly certain. So what if we tried something else? If I try use this thing as foo, lexical error, because missing the, there we go. So I do parse this correctly because there isn't the ambiguity, there isn't the shift reduce conflict, and I do get a module that contains one import with the path, which is this thing, and I import it qualified with just the foo alias. Okay. So we found our first parse error that needs to be fixed. What else? Const foo equals 42. Ah, it's going to be passing an expression. That's going to fail. Because... Oh, because it's also expecting a type. And it calls undefined because of the expression, so that doesn't work yet. But that's expected. Not a surprise there. I guess type foo equals int undefined. Why do we have... Oh, because passing types, not done yet. Do I have anything I can do without passing types then? I guess functions? No, an enum. What's the syntax? Okay, so that works. At address 0, line 1, colon 1, we have an enum named foo with values bar and baz. Okay. A struct, I'm gonna need types, so I can't do that yet. But a function, if it doesn't have arguments nor a return type, that should parse. It does. This is a function declaration name main with no arguments. Oh, does it pass generic arguments correctly? Yep, this is a function main with a t generic parameter. That worked. And while within the expression, if within the expression, let within the expression, do I have anything that doesn't require an expression that I can try? I can try break. Excuse me. Break and continue, I guess. And return. They are wrong. They're in the wrong place there. But it should parse. And it does parse a function main with a generic parameter t, no arguments, and no return type, with a body which is a break statement, a continue statement. Oh, it's all saying... Oh, because yes, I didn't put any new line. There we go. Then a continue statement, and then a return statement with nothing as its argument. Okay, so we found a few interesting things. we know that since we haven't done expressions yet, like it's very hard to pass anything that is meaningful. And we have found our first like significant shift reduce conflict where the code gets confused. I'll have to figure out how to fix this. So I'm gonna stop here because I've been in this for more than 4 hours and my brain is fried. But to sum up, today we have fixed the comments that we're missing in Alexa. We've talked about the identifier problems with Alexa. We fixed the fact that identifiers could not start with a keyword. We fixed that. We've implemented the first pass of the AST that has everything but expressions and types. With I could do types quickly. No, I'm gonna stop here. And we're using the trees that grow extension mechanism to be able to have types that depend based on the phase of the parser. We've implemented most of the grammar for everything up until expressions, and we have fixed several issues in the grammar, including several shift reduce conflicts, but clearly not all of them. Okay, well, that's pretty decent. I'm gonna stop here. My to-do list for next time is figure out what's wrong with the shift reduce. I mean, I know what is wrong with the shift reduce, but like try to see if I can figure out how to solve this without rewriting the grammar. And then next time, I suppose we'll finish parsing expressions, which should not take as long as it took this time because at least we know what we're doing this time. And after that, I think I'll take a break and do some of the bytecode and image generation just to take a break and do something a bit easier. I'll try to do a stream on Thursday. I'll update the Twitch calendar when I know for sure. And yeah, I'll commit this when I'm done. Perfect. Well, thank you everyone. That was fun. That was a lot. It was a bit stressful to see it not work at the end, but we figured it out. And yeah, see you next time.